Yes. Good evening. Pallavi, thank you. Thank you so much. Right. We have discussed PMMC and MI completely we have taken, and EMMC introduction we have taken, right? Now, let us continue the total discussion. Sir, before taking that entire thing, I will revise the topic. Just brush up, I'll give you. Right. So here in PMMC, what is the measurement? Only DC. Okay, means I average, simply average value only. Okay, MI, AC, and DC also there. So if you are giving DC average value, it will measure. In AC, RMS value, it will measure. But both are for either as an ammeter, as a voltmeter, either as an ammeter or as a voltmeter. Okay, right. After that, sir, in the PMMC, what is the torque equation? TD is equal to BIN into A, and theta equation is BIN into A by Kc. Okay, after that, sir, in the PMMC, what is the ammeter extension? What is the ammeter extension? Right, the ammeter extension is, what is that? RSH. What is the formula? Rem by M minus 1. And voltmeter extension, RSC is equal to Rem into M minus 1. This is complete thing related to PMMC. But few people asked in the yesterday's class doubt session, what is it? Here is, sir, why we are going for extension? Why not for high range voltmeter or ammeter? What I told, if other range ammeters or voltmeters are not available with us, can we measure or not? Yes, we can measure. That is why we have taken extension of range of corresponding devices. Okay. Sir, in MI instrument, in MI, what is the top TD formula? TD is equal to half I square dl by d theta. Okay. After that, theta is equal to half I square by kc dl by d theta. Okay. So in this, what is that? ZSH, same formula. ZSH is equal to Zm by m minus 1, and ZSE is equal to Zm into m minus 1. Similar formula I told you. But in this MI instrument, as it is a AC device, AC supply related errors also will be there. That is frequency error we said. AC supply related also will be there. So what is that? Frequency is there. Suppose if the supply frequency is varied, the winding, the corresponding element X will be changing. As X is changing, current drawn or voltage drop, everything will be changing. So therefore, in order to overcome that, what is the formula? Tau SH is equal to tau M. Tau SH is equal to tau M. Okay, after that. So in this, C is equal to 0.41 Lm by RSC square. Okay. One student asked one doubt, I think Mubin, right? It's a very good question. Concentrate. Sir, if I simplify that, I gave the total derivation, you proceed, I told you, no. If you take the derivation, you will be getting C is equal to Lm by RSC square only. Yes, but what I told you, while you're deriving, some assumptions must be taken. What is that? Wherever the small values are there, neglected, etc. That's why if any smaller values are there compared to larger values, you can neglect it. By neglecting that, you will get this one. But sir, if you don't neglect those, what is the exact value that is experimentally proved that this formula as this one experimentally given, right? If you take this only, so therefore, as we have neglected the small values in the entire explanation, if you proceed with the normal method, experimentally only, this is given 0.41 lm by RSC square. So this is the total discussion we have taken so far in the earlier class. Clear? Right? Okay. After that, we have taken one more thing. Sir, what is that? EMMC, introduction I gave you. EMMC introduction. Sir, what is EMMC? What is that? Electromagnet moving coil instrument, and what is it? Dynamometer type instrument. Dynamometer type instrument. Okay, sir. In this, how many coils will be there? Two coils. One is the fixed coil and one is the moving coil. Okay, fixed coil is generally, this is a designing stage. I told you, fixed coil means it is in series in the circuit. Moving coil means it is parallel in the circuit. Okay, sir, as it is series means series connected coil device. So simply it is called as, what is it? Current coil. CC we can say. It is called as current coil. This is PC, potential coil, or we can say pressure coil. Right? Potential coil or pressure coil. And sir, here this fixed coil or this current coil has the resistance of which one here? R must be low because ammeter concept. Potential coil R must be high. This is a general idea, right? Whatever we have taken so far, same thing only in terms of this we have taken. Okay. So my question here is, sir, if I connect one coil in series, I connect one coil is in parallel, automatically which will be there? Which will produce a power will be available. Why? This is related to current sensing. This is related to voltage sensing. So voltage into current, automatically are going to get power. So that's why with the EMMC, power can be measured. I told you, right? I'll prove it, no problem. But also current and voltage, I told you. Here small doubt will be there. Sir, how the current and voltage are possible? I'm going to show everything clearly one by one. First, I will be taking power measurement. After understanding the concept and mathematics of power measurement, we will be going to EMMC as an ammeter, as a voltmeter and all. Then we can say, therefore, EMMC can be used for measurement of power, current and voltage. But few cases drawbacks will be there. After seeing the total errors and all, EMMC is preferred for dash. We are going to conclude. Clear? Right. Now the question is, sir, first I'll be taking power. Power means one coil must be in series. One coil must be in parallel. So therefore, EMMC itself is combination of two coils. Okay. Right. Symbolically, generally, sir, current coil, I'll show the symbol, no problem. Current coil means less resistance. Less resistance symbolically, how do we show? Only 1 or 2 turns only will show. Only 1 or 2 turns. Okay. Now, second, sir, potential coil, high resistance will be there. So therefore, more number of turns we show. Why? R is equal to rho L by A. What is it? Length is more. Automatically, resistance is more. Here, length is less. R is equal to rho L by A. L is low. Simply, resistance is low. This is what the simple example. Okay, that's why symbolically this is what the thing, because in the diagram, sometimes based on the diagram only, by using this, okay, it is CC current coil, it is lengthy number of turns, so that it is potential coil, like that you should see. Clear? Right. Now, with all these introduction, I am taking the circuit diagram. Sir, what is that? See here. Sir, this is the circuit here. Concentrate. Here, this is the fixed coil. This is the fixed coil, right? Fixed coil, I have given that as current coil also. Like this, it is connected. and one more fixed coil part. Sir, why two parts? I'll tell you, no need to worry. I will give you why this is two parts. Means one is fixed coil, one is also means fixed coil is made into two parts. Why? I'll tell you. Sir, this fixed coil is, concentrate here. This fixed coil is coming in series in the circuit or parallel in the circuit. Fixed coil is coming in series because it is supply, coil, load, and everything is coming like this. Therefore, series in the circuit. That's why what I told you yesterday, fixed coil series in the circuit called as current coil. First point. Okay, after that, this box is which one? Potential coil. This box is potential coil. Right. This is coming in parallel like this. Means to the supply, it is coming means automatically parallel circuit. So therefore, potential coil is connected in parallel notation. Two coils connection. Okay. Sir, what is this R? See, already told you, sir, resistance of the potential coil must be high. Yes, high only. But to indicate that, to show that high resistance, simply we give the symbolical representation like this. Means high, more number of turns are there. More number of turns itself indicates high resistance. But in order to increase its resistance further, I told you already, voltmeter with 1200 ohm resistance, voltmeter with 2400 ohm resistance. Among these two, 1200 is high resistance only, but compared to 1200 voltmeter, 2400 ohm is very high resistance. I told you error is less. Here error will be less only, but here very less will be there. We have taken one question also in the loading effect concept. That's why voltmeter should be designed with as high as possible resistance. Same way, potential coil is designed with as high as possible resistance. Okay, that's why even though this coil is having high resistance, symbolically in the circuit wise, one more resistance we keep. That resistance is called as simply, what is that? To limit the current. Yes, high resistance is there, less current will flow. To limit the current, we can say. Okay, that's why symbolical also. Sir, this is the potential coil, and along with that, resistance is connected. That is what R. So therefore, always the potential coil with R only, the general symbol, to indicate that this R, if you see that, okay, potential coil is having as high as possible resistance, we can say. This is what the simple idea. Okay, right, sir. After the terminology, here, this center point, this center dot, this is spindle. This is a spindle. Okay, and whatever this is there, that is spring. Only I'm showing one spring. Means, listen carefully. If this is a spindle, one spring at the top, one spring at the bottom. But if you see like this, how many springs you can observe? Only one spring. One behind the other will be there. But if you see like this, only one spring. That only I'm keeping just one spring. Right? Okay. After that, here this is air friction damping chamber. Very, very, very small capacity chamber, air friction damping chamber. Okay, check it here, sir. Two coils are being taken. So deflecting torque setup is being taken. Right? Spring is there. Therefore, controlling torque is also there. Chamber is there. That is damping chamber is means damping torque setup is also available in this. Okay, right. Now, with all these things, I'm taking the corresponding explanation. Sir, this is the pointer. Yes, corresponding scale 0 to something. Okay, now, so supply is given. The moment supply is given, the current will be flowing. At this point, current will be divided. At this point, current will be divided. As the current is divided, that is IC and this is IP. IC and IP. Okay, sir, IC is flowing. IC is flowing through the current coil. IC is flowing through the current coil. That is the reason why the IC called as current coil. Okay, this current is nothing but actually like this here. This is the coil, but structure wise I'm showing it box. This IC as it is flowing through load. So IC is equal to IL. So we can say that IC is equal to IL. Okay, sir, across the load anyway, we say that VL load voltage, current is IL, we can say simply. Clear? Right, sir. IP, again it is IP. IP is flowing through. IP is like this. This is the coil coming like this. So therefore, IP is a potential coil. This is a simple construction part. Now I'm taking the operation. Come on, guys. Now I'm taking the operation. Same thing I'll explain here. Concentrate. Sir, after giving the supply, right? What will be there after giving the supply? What will be happen? Concentrate, guys. Right here, this is moving coil. That is potential coil. Already told you. This box is there. No, this entire box is connected in parallel. So this box is means this one. See this box is moving coil. Moving coil is connected in parallel in the circuit. Clear? Okay. Now the question here is, sir, here IC is flowing through the coil. So therefore, what will be there? IC into picture. Sir, IP also flowing. IP into picture. Okay, sir. One is high resistance, one is low resistance winding is there. So automatically between these two, phase angle difference will be there or not? Yes. Why? It is RL combination coil. It is also RL combination coil. Therefore, these two will be differed by some angle. So generally, how do we take that angle? Cos of something or cos of phi or something we take. Simply cos of something. Okay. Now, very, very important point is, sir, when the torque is produced, means consider guys, operation explaining with the mathematics. Supply is given. Yes, phi C will be into picture. Here, phi C is there because IC is there, exited, phi C will be there. IP is there, exited, phi P. Sir, both fluxes are linking with each other. As both the fluxes are linking with each other, what we can say, so this is the movable system, right? Current carrying moving coil, current carrying moving coil placed in the magnetic field of current coil. So therefore, what is that? One current carrying conductor placed in the magnetic field experiences a mechanical force. Yes or no? Thereby, which is produced here? TD is produced. Okay, sir, once the TD is produced, rotation is being started. Once the moving coil and spring and pointer starts moving, starts rotating, then the springs gets disturbed. The springs start getting disturbed. That disturbance in the spring automatically, which one here? Produces opposing force. Very simple. Sir, as it is keep on getting rotated. What do you mean by that? The springs will be keep on getting disturbed more. At one point, what will be there? The pointer will be getting equal force from both the sides. What happens here? TC equal to TD. Sir, the moment TC is becoming TD, automatically the pointer tries to oscillate. Then damping chamber anyway there. That damping chamber automatically stops the oscillations. Now again tell me guys, do we have any change in the corresponding operation? No, operation is same. Supply is given, effect will be there, TD is produced, rotation being started, springs gets disturbed, opposing force is produced. Then at some point TC becomes TD. Yes. Then what is that? The corresponding damping chamber comes into play. That's why I'm repeatedly saying this point here. That is the reason why when we have taken spring control and deflecting torque, etc., much time I spent. So that why I'm repeating these statements, at least you can recollect everything. This is what the construction operation. Now, mathematical discussion. Sir, what is a mathematical discussion? Sir, whatever the TD produced is proportional to phi C. Definitely, based on the flux strength only, both fluxes will be linking. And TD is proportional to phi P. TD is proportional to phi P. Means TD proportional to phi C, TD proportional to phi P also. Sir, these two are together acting. So therefore, what we can write here? TD proportional to phi C into phi P. Clear? But, sir, what law I gave here? Current carrying conductor placed in the magnetic field, experiences a mechanical force. Okay, but sir, whatever the force is produced, that will be depending on mutual inductance between these two coils or not. That will be depending on mutual inductance between these two coils. Yes. So therefore, based on the mutual inductance only, yes, we can get the corresponding thing. So that's why not only this mutual inductance also playing the role, but how can we take that mutual inductance? Means concentrate. TD proportional to phi c, phi p, and correspondingly dm by d theta. Sir, how? I told you in the earlier class, complete derivation I give. What is that? The change in inductance, change in theta, both are together. Here also same thing. Sir, this is the coil. At the time of starting, it is there like this. After some operation, the moving coil becomes like this. Sir, here to figure 1 to figure 2, the mutual inductance between the fixed and moving coil, same or different? Different only. Based on the change in mutual inductance only, yes, change in the deflection will be there, this one. So therefore, what is it here? Change in mutual inductance to change in theta is also playing the role. So that's why be clear with the terminology. In this entire thing, not only flux, not only current, but also mutual inductance plays a role. But sir, why only you can take, or how you take dm by dt? Means in the yesterday's discussion we have taken TD depends on dl by d theta. Same thing here also. Here mutual inductance dm by d theta. Okay, sir, what is phi c? Phi c proportional to ic. Okay, I'm writing ic. Phi p proportional to ip. I'm writing ip. But sir, these two are not in same phase. Why? One is low resistive, one is high resistive. That too, the current coil resistance and inductance both will be there. Potential coil also resistance and inductance both will be there. Definitely one is more resistive, one is less resistive. Automatically the angle difference will be there. Angle difference will be there. So automatically what we can write here? IC IP cos of something. Phi or phi minus 25, we don't know, some phi into dm by d theta. This is the total construction, operation, and mathematical discussion of the corresponding EMMC instrument. Clear? And people are having, sir, if resistance is different, how the phase angle comes into picture? Very simple, yeah. Here, this is one triangle R. Okay, some angle. Sir, I'm increasing the R. I'm increasing the R. Do you get same angle here? Definitely no. That is the reason why, as the resistance values keep on getting changed, so automatically angle will be keep on getting changed. Definitely. Clear? So this is the complete operation of the EMMC instrument. Clear? Right? Okay. Now elaboratedly, I'm showing point by point. I'm showing point by point. Right? X is reactance of the coil. Definitely be clear. Even the coil shows like this. Coil is shown like this. R will be there, L will be there. I'm not commenting about L anything now. I'll be taking later. But as of now, the current coil should have less resistance. Potential coil should have high resistance. That only. The inductance is the reactance of the corresponding coil. That's it. Right. See, I told you already, in the EMMC only 2 coils, but why you have taken 3 coils? I have not taken 3 coils. I told you clearly, fixed coil is made into 2 parts. Why? I'll tell you later. When I was giving, when I'm giving, kindly take it. Up to that, kindly have the patience. Why the 2 parts of the fixed coils are there? Why the 2 parts of the fixed coils? Everything I'll be taking. Okay, so this is phi c, phi p. Based on phi c, phi p, we are writing a step-by-step notation. Clear? Simple logic here. R proportional to L, R proportional to 1 by A. How do you write the combination? R proportional to L into 1 by A. Same thing. TD proportional to phi c means based on the current coil flux, based on the potential coil flux, based on the combination of the coil fluxes phi C and phi P. That is what the complete mathematical analysis. Clear? Right? So therefore, if two coils are placed nearby each other, if two coils are placed near to each other, automatically between these two, mutual inductance will be there. Based on the position of those coils, mutual inductance. So therefore, our force is rotating the moving coil. Our force is rotating the moving coil like this. So automatically, mutual inductance between current and potential coil will be varied. Yes, dm by d theta. Now this entire thing, step by step, I'm showing. Right, concentrate. So far, I have drawn the diagram. And one more way of showing here, sir. This is a circuit diagram represent. This is construction diagram base. This is a circuit diagram base. Sir, fixed coil, current coil, fixed coil, current coil. But, sir, in order to show that only I have taken as it is, in many of the figures, either in the textbooks or anywhere you see, fixed coil, current coil has so many number of turns, not at all acceptable technically. Not at all acceptable technically. Even though you're finding all these things, kindly this is wrong only. This is wrong only. In order to show that I'm giving this figure. What is it here? Here, what you have to take? The fixed coil, only 1 or 2 turns. Fixed coil, only 1 or 2 turns. That's not the point. Okay, after that, sir, fixed coil is connected in series with the supply. Okay, series. So next, moving coil, yes, potential coil connected in parallel with the supply. This is the line like this. So therefore, this is coming in parallel only. That's what I have given. One more circuit diagram representation. I told you now, series resistance to limit the current we can say. And scale, watts I have given, sir. Why means one is in series means current, and one is in voltage, one is in parallel means voltage. Current into voltage combination means power only. That's what the simple point. This is the circuit diagram of EMMC instrument. Now let us take the mathematics. Sir, all I told you that. Sir, what is that? In the instrument, AC supply based, I'm asking. AC supply based. Sir, IC, IP, cos phi, dm by d theta. All I told you. IC, IP, cos phi, dm by d theta. Right? I'm taking. Sir, what is IP? If you see this diagram, sir, IP can be written as which one? Supply voltage V by what is it here? Total opposition of the coil. What is the total opposition of the coil? ZP we can say. Why? Resistance of the potential coil, reactance also there in the potential coil. This box is potential coil. Therefore, ZP we can write. Okay. So therefore, here ZP means V phase by ZP, opposition notation. Cos phi dm by d theta. Sir, for a designed instrument, ZP will be constant. Can you change the potential coil impedance after designing? No. And if dm by d theta is also constant, sir, why? Simple logic, sir. Both coils are strong mutually coupled. More force is produced. Come on here. More mutual, more force. More force means more theta. Again, concentrate here. The theta and mutual inductance change will be happened together or will be happened separately means will be happened together only. Clear? So therefore, what you get here? If two coils are strongly coupled, right? Strong force will be there. More movement will be there. More movement means automatically more displacement, more theta we can say. Right. So after that, if I'm writing, if dm by d theta is constant, so therefore what we can write now, if dm by d theta is constant, ZP is also constant. So we can write TD proportional to IC, V phase and cos phi. IC, V phase and cos phi. Sir, IC, V phase, cos phi. What is it here? V into I into cos phi, single phase AC power. That's why in this device, whatever the pointer shows some value, that is power formula, power value only. How means? One is current, one is voltage, angle between those two. So automatically power will be in picture. That's why in the yesterday's class, current we measured, voltage we measured, but now we are measuring the power also. And second thing, sir, people are asking, sir, why we are connecting the load? We are measuring the load power only. We are measuring the load power only. This is the device. Concentrate, guys. Concentrate. This entire box is the device. Means here some load is there. What is the power consumed by the load? How do you connect? Wattmeter like this. Series and parallel wattmeter. That is what I'm showing. So that's why without the load, which you want to measure here, if you are not connecting the load, which you want to measure, so definitely we need to talk about, yes, load must be connected. Clear? Right? So therefore, in this entire formula, V phase, ZP, yes or no? V phase by ZP means IP. So ZP constant, DM by the constant. Therefore, my question is, if we are connecting one coil is in series, one coil is in parallel, are we going to get the power measurement or not? Yes, power measurement proved here, single phase AC power. Sir, if this is AC, okay, okay. Sir, if it is DC, if it is DC, how can we get it? If it is DC, how can we get it? In DC, what is the phase angle? What is the phase angle here? 0. So therefore, now, sir, if it is a DC, what is that? TD is proportional to, if it is a DC, TD is proportional to, which one here? IC and IP only. Why? Cos phi. Cos phi simply we can say cos phi equal to 1 by DC. No power factor means 1. And what is IP? We have to write. Concentrate here. Sir, IP means this is IP. Sir, IP means voltage by ZP we have to write. But is it DC operation or AC operation here? DC only. That is the reason why we should write only RP, not the ZP. Only RP. Why not? Why not ZP only RP means because it is DC. DC means reactance will not be acting under steady state notation. Therefore, we should say V by RP. V by RP. Okay. So therefore, here V by RP. Okay. So again, after designing, anyway, RP will be constant. We cannot change the coil dimension and all. Therefore, TD proportional to, IC into V. That is DC power. So therefore, if you are able to connect one coil is in series, one coil is in parallel, yes, we are going to measure power. AC supply, AC circuit is there, AC power. DC supply, DC circuit is there, DC power. This is a complete conceptual based mathematical proof. Conceptual based mathematical proof. Clear? Right. Now people are asking, sir, how do you measure? How can you measure current alone? What I told you, I am explaining power measurement first. Let me complete the power measurement. After the power measurement, I will go to current and voltage, etc., etc. Everything will be clear. Okay. First, let me complete power measurement. In this power measurement, you are not getting IC separately, IP separately. Measurement is not possible. Mathematically, we are taking, but what I told you already here, TD. Proportional to phi C, proportional to phi P means both are combinedly giving. Phi C means current, phi P means voltage. That only we have done here. Yes, current. Phi P means IP. IP means V by ZP. Therefore, what is it? Based on the coils, we are getting the corresponding power measurement. This is how we are measuring the power. This is how we are measuring the power. Clear? Right. Clear, guys? Right. Now, the question here is, so DC power is also over. AC and DC. As of now, we have done only which one here? AC power measurement, circuit, operation, construction, mathematics. DC power, same thing we have taken. But now, sir, what is the circuit diagram? How do we connect? how do we connect in the circuit? What is it? This is circuit diagram I have shown, circuit diagram. But in the laboratory, sir, how do we connect? In the laboratory, how do we connect? Means you need to understand one thing, sir. Here, in this, how many coils are there? One is current coil. Current coil has two parts. No, why current coil has two parts? I'll tell you. I will tell you. I'll conclude with that only. No need to worry. Sir, potential coil is like this. Potential coil is like this. One is current coil and one is potential coil. Current coil and potential coil. Now, sir, how do we connect these in the circuit? Be clear, guys. Sir, two coils are there. Be clear. One general doubt, genuine confusion. This is what is that? You know, sir, all these are already connected into the circuit. No, yeah, no. This is our wattmeter, EMMC wattmeter. Okay, this terminal brought out here. This is also brought outside, brought outside, brought outside. Means four terminals are brought outside the corresponding device. Okay, after bringing those device, what will be the terminology? What will terminology means? Concentrate. I'm giving here, sir, current coil and potential coil. Sir, this terminal is called as M. This terminal is called as L. The current coil has two terminals. One is called as M, main. I'll give that later. L, load. And potential coil has two terminals, C and V. C means common, because one in series, one in parallel means common point is required. And V, voltage. Main, load, common, voltage. My question is, sir, these MLCV terminals are left free by the manufacturer or permanently shorted? Means left free by the manufacturer, because see, this is M, this is L, this is C, this is V. Like that, all the four terminals are brought outside. Brought outside. Our duty is to operate this as here wattmeter. Okay, sir. Here my circuit is there. This is what? Supply terminals. In your laboratory, panel board something, supply. And this is your load. Sir, you want to measure load power consumption or power consumed by the load and all. So how do we connect this? This is the device. Okay, these windings are in the circuit, but terminals are brought outside. So how do we connect? To measure power. Power measurement means no one should forget. Power measurement means one will be in series, one will be in parallel compulsory. One will be in series and one will be in parallel compulsory. Clear? Right. Sir, concentrate here. Now I'm taking that. Sir, here in the EMMC instrument, there are two types of power measurement connections again. Sir, one is concentrate. One is MC short. MC short connection is there. MC short connection. And other one is LC short connection. MC short and LC short connection. But be clear, whatever the yellow color it is visible, this is current coil. This is potential coil. Current coil and potential coil. The first task here is, sir, I want to connect this circuit. I want to connect this circuit as the wattmeter. Therefore, concentrate here. Current coil must be in series with the load. Current coil must be in series with the load. Okay. In the same here also, sir, current coil is in series with the load. Okay, sir, potential coil must be in parallel in the circuit. So that's why I'm taking here potential coil is connected like this. Now verify. Sir, current coil is in series, potential coil is in parallel. Yes, thing is done. In the same way, current coil is in series, potential coil must be in parallel, means other way of possibility is like this. See, as this color is not visible, I'm drawing this again. Clear? Now verify. Very, very important. Sir, this is M. This is L. This is C. This is V. Okay. And here, this is M. This is L. This is C. This is V. Sir, what is our task? One coil must be in series. Yes, series. Yes, series. Okay. But other coil must be in parallel. Yes, parallel. Yes, parallel. But what you have to understand here is, sir, concentrate. Sir, this coil is series in the load directly, right? Coil is parallel with the load, with the supply directly, with the supply directly. Okay. Now, if you come back to this, sir, coil is in series with the supply directly. Coil is in parallel with the load directly. Means what you understand here? Series or parallel in the circuit we require. First case, current coil directly series with the load. Potential coil directly with parallel with the voltage. Second case, current coil directly series with the supply. Potential coil directly parallel with the load. No need to worry. One must be in series, one must be in parallel. That only we require. So therefore, in the power measurement, there are two methods available: MC short and LC short connection. MCO shorted, LCO shorted. Now, among these two, in your laboratory, most of the cases, you have used only which one here? MC short only. MC short only we are going to use. Sir, why? I'll tell you later. But both are equally good according to the given condition. Both are equally possible. According to our requirement, if the wattmeter is given to us, MLCV terminals will be there. Yes, M to supply, L to load, C to correspondingly either M or C, means either MC short or LC short. In that way, you need to take the corresponding connection. Now you can measure power. But how do you measure the power means? Already told you, corresponding discussion. Okay, right. People doubt here is, sir, what happened to cos phi? Cos phi equal to 1. Okay, and what happened dm by d theta? Already you written here, dm by d theta is constant. That's why you written proportional symbol removed. IC into V by RP, RP constant, IC into V, DC power. DC power. So this is the total construction, operation, and mathematics of power measurement in the EMMC instrument. Power measurement in the EMMC instrument. Right. Most of the cases you have used MC short only. Why? Also give the reason. No need to worry. But MC, LC, both are having their own advantages. No need to worry. Own advantages are there. Don't worry. I'll tell you. Okay, now the task here is, sir, I want to measure the current. Which one? With this device, I want to measure the current. Just now I told you, sir, this is current coil. Okay, this is potential coil. Sir, these two are not shorted directly. These four terminals are left free. M, L, C, V like this. All terminals are left free, right? MLCV full form, I will give you already. I told you. Wait, I will give you. I told already. I will give you later. Right? And one more thing. Very good question. Sir, with a single wattmeter, how do you measure AC and DC? Come on here. With the wattmeter, EMMC, yes, AC wattmeter, DC wattmeter. Accordingly, they will design the structure. What is it? AC wattmeter, DC wattmeter separately. But my topic is EMMC topic. That's why EMMC can be used as an ammeter, as a wattmeter, DC measure, or AC power measurement also. That's why don't think like with single device, two, not possible. DC wattmeter means, okay, I'll write here. So AC wattmeter means they will give like this W and they will give this symbol. It indicates AC wattmeter. Suppose DC wattmeter means W underline will be there. Underline means constant DC. In that way, they will design. We need to use it. That's it. Right? Okay, come to the point. Sir, now I want to measure the current. Sir, current measuring device means the device must be connected in only in the series in the circuit. Okay, Sir, this is our EMMC, right? This is our supply. Here our load. Okay, supply is there, and this is load. I want to measure current through the load. I want to measure current through the load. So which device is there? EMMC is there. Sir, in EMMC, two coils are there like this. Now, how do we connect? Means this entire circuit should come in series in the circuit. So no, the entire device should come in series in the circuit. Should come in series in the circuit. Clear? Right? Now, how it is possible? I'm giving. Right. And Harshit Reddy, all I told you, don't type more than one time. Otherwise, don't come to the class. Openly, I'm saying. By mentioning the name, I'm saying no. Right? 2 times, 3 times, 4 times, continuously, I'll be missing other people genuine doubts. You want to disturb me? Kindly don't come to the class. If you want to have the clarification, until I clarify, they would wait. Clear? Even if you feel bad, I'm saying openly. Because every time this is happening with the people continuously. Right? Now, sir, now people are asking one genuine question. What is that? Sir, AC, negative half cycle will be there. No, you're missing something. What is that? EMMC, electromagnet moving coil, electromagnet, positive and negative. No need to worry. What is it? Yesterday I told you clearly. EMMC, nothing but electromagnetic structure, either MI or EMMC, applicable for both DC and AC. Why? Why? Positive cycle, current is positive, B is positive, torque is positive. Negative cycle, current is negative, B is also negative. Why? This is the electromagnetism. Therefore, torque is positive only. Torque is forward only, forward only. No problem at all. That's why don't forget the basics what we have taken so far. Okay, sir. Now tell me, this device must be connected in series. How is it called? Very simple. Very, very, very simple. I'm connecting this here. What is this? M. Okay. This is L. This is V, right? I'm connecting L and V like this. And I'm connecting C here. Now tell me, this device is perfectly coming in series in the circuit. Perfectly coming in series in the circuit. Clear, guys? This is one way of possibility. Like this, many ways are there. Those who are on the line, kindly concentrate. Don't ask the same statement again and again. Sir, this is one of the possible connections. Like this, so many things are there. You can take any connection, but the structure must be coming in series in the circuit. But in my explanation, I am giving only one circuit because this circuit also we don't prefer in future. Why? I'll tell you. That's why possibility is there or not. Possibility is there. Two coils are given to you. Yes, you can get this entire circuit in series in the line. So no need to worry. Okay, this only I'm showing clearly here. Sir, as an ammeter, nothing but EMMC as an ammeter. So far we are taken as a power device. Here I'm taking the as an ammeter. So what is that? Check it here. Concentrate. Sir, fixed coil. Sir, fixed coil means current coil one part, fixed coil second part, coming to the moving coil and coming over here. That only have shown clearly here. Current coil connected here and the moving coil like this. But this is shown above side. No problem. This is what the thing. Okay. Here anyway load will be there. Here anyway supply will be there. Now check it here. Sir, current through the current coil and potential coil will be same or different? Same. So that's why be clear. Sir, cos phi everything is common. Just normal idea I'm giving. IC and IP. Cos phi d, that is common. Leave it. That too, it is a current measurement. No, here voltage and current will not be there. Both are coming in series. So therefore, cos phi no need to take. Why? Cos phi comes into picture when one is voltage, one is current notation. So therefore, IC, IP only I'm writing. Okay. Now, sir, IC is I. IP is also I only. Therefore, I into I square. TD proportional to I into I square. I into I square. Actually speaking, what we have taken, sir, dm by d theta will be there here. So simply dm by d theta will be there. Otherwise, you can write like this also. Dm by d theta. But anyway, it is constant. No, as it is constant, TD proportional to I square by 2. Sir, deflecting torque is proportional to current parameter. Of course, square. Of course, square. Therefore, what is it here? Yes, here this entire thing is with respect to which one? Current measurement. Why? TD proportional to I square. I square means current measurement only. Okay, but kindly try to understand my statement. See, I'm using very simple English. Every common person can understand my English. Kindly understand the statement. The connection is possible or not possible. But so error is more, that is there, this is that will be taken. I only take. You need not to get tensed. I will be taking that. Kindly wait. Connection is possible or not? Yes, if you are able to connect like this, possibility is there. Yes, TD proportional to I square. Okay. Next, sir, I am showing clearly now in our discussion. What is that? Here, M is to the supply, L is to the V, and C is to the corresponding load. This only I have shown here from the circuit diagram. But this is our picture. Clear-cut picture is there. In this way, we are going to get the corresponding thing. Okay. Now, sir, TD equal to I square, we got it. TD equal to I square, we have got it. Okay, sir. What about TC? TC is Kc into theta y, spring control. And at the final position, TC equal to TD equal to Kc theta equal to I square dm by d theta. What is that? TC Kc theta. TD I square dm by d theta. So automatically theta is equal to, what we can write? I square by Kc dm by d theta. Okay, and we know that, sir, Kc is constant and dm by d. Anyway, that's why I'm writing if dm by d theta is also constant. Already I told you in this class, actually it will be constant only, but approximate. That's why I'm writing specially. If dm by d theta constant, theta proportional to I square. Sir, theta is proportional to I square means, is it current measuring device or not? Yes, it is current measuring device. That's why my practical question is, if I give you an EMMC instrument, are you able to measure current in the circuit or not? Yes. How? Means this is one of the possible. L to V, C to here, M to here. This is what the possible, one of the possible connections. Okay. No, people asking, so why not something else? That one I'm saying every time here. This is one of the possible. Other connections are also possible. See, sir, current coil, potential coil, supply. Okay, sir, this is M, L, C, V. What people are asking, sir, M anyway mains. I told you, I'll give you later. No problem. Mains. Okay, sir, why L to V? Why not L to C and V? It is also series. Check it. Every branch, the total structure is coming in series only. You can follow this also. The two, there is no much operational differences between these two, no problem. That's why, is it possible or not? Yes, possible. That only I'm giving. Yes, both connections are possible. The two, many connections are possible. Many connections are possible. Clear? Right. Why we have not taken cos phi means both are coming in series only. Both are coming in series only. A series means both are related to current only. Voltage related connection itself is not there. If voltage related is there, angle between voltage and current, what is it? Cos phi we have to take. But here both are related to current function only. Current function only. Clear? Right. After that, simply I'm writing this one. Okay, right, sir. Now theta proportional to I square. Now theta proportional to I square. Finally, you are getting theta proportional to I square only. Clear? Be clear, guys. If I remove this dm by d theta, td proportional I square. If I keep dm by d theta, td is equal to I square dm by d. That's why I have not written this first. This approximate answer. This is the final answer. That's why I have used equal to symbol, no problem. Theta proportional I square. So which scale? Non-linear, non-uniform, square law scale. Okay. But I'm going back. Sir, AC power is there. So what can be the scale of this one? What can be the scale of this device? AC power measurement scale is dash. What can be the scale of this device? Clear? So therefore, cosine phi is there. Cosine phi is there means automatically non-linear scale only. Therefore, in this power measurement, which one? AC power measurement, linear scale. So sorry, non-linear scale. Okay. So coming to DC power, do we have any cosine phi or time varying function, etc.? No, constant only. That's why be clear with the terminology. In the DC measurement, in the DC wattmeter, scale is linear. In the AC wattmeter, the scale is non-linear. Which one? Cosine based non-linear. In the current measurement, the scale is which one here? Square law scale. That is the reason why all these devices will be separately to be constructed. Separately to be constructed. But some problems are there, I'll tell you later. But see, I told you already, concentrate. Sir, how do you get the exact value? Error will be there, etc. I'm not concentrating on the error now. I'm concentrating only on whether the connection is possible or not. Yes, possible. If it is possible, we can say, yes, with EMMC, power can be measured. Yes, and with EMMC, current can also be measured. That's not the first point. Okay, next. Sir, how do we get the voltage measurement? Sir, voltage means concentrate. Sir, this is our instrument. What is that? Current coil and potential coil. Current and potential coil. Okay, sir, this is my supply line. This is my load. Okay, right. Means in the circuit. Right. So this must be operated as voltmeter. Means this device should come. This device should come in parallel in the circuit. Should be in parallel in the circuit. How do we connect? Here also 2-3 different connections are possible, but only one I'm showing. Simple circuit connection. Right, sir, what is it? Here. So what I'm doing, this device should come in parallel, right? Simply here to here I'm connecting, here to here I'm connecting, and here to here, like this I'm connecting. Now tell me, this device is in parallel in the circuit or not? Yes, definitely this device comes in parallel in the circuit. This is one connection. Okay, second connection. Here, same thing. Sir, here to here and here, like this. Still, it is in parallel in the circuit only. Therefore, our topic is what? The instrument should be coming in parallel. Instrument should be coming in parallel in the circuit we require. Yes, that is done. That I'm showing clearly in this. Sir, this is MI voltmeter structure as a voltmeter. Sorry, not MI, sorry. EMMC as a voltmeter. Check it here, sir. Current coil, potential coil coming in parallel in the circuit. Parallel. That only I have shown here. Yes, current coil, second part, potential coil, and the resistance already there in there. Therefore, in the circuit, same thing, circuit as I'm showing. After that, this is the load, this is the supply common. Now also, sir, in this, what is the series and parallel circuit? Both are not there. Only one circuit. What is it? This entire circuit is in parallel in the line. Okay. But sir, TD proportional, what I told you, IC into IP is a basic function. TD proportional to 5C into 5P means IC into IP is a basic function. So therefore, be clear, sir. TD IC into IP. What is IC? Current through the current coil I. So what is IP? IP also coming in series means these two coils are in series, but in parallel with the circuit, lot of difference is there. So that's why what we should say, I into I square, I square. So what is I? V by Z total. So in the same way, we can write V by Z total. Z total is constant. We can write TD proportional to V square. There we have got TD proportional to I square. Here we are getting TD proportional to this. Obviously, it is parallel. Yes, voltage concept only we will get. I'm coming again. So TD depends on current coil current and potential coil current. As these two are series with each other, automatically IC I into I square. I square means V square by Z square. Simply Z total is constant. TD proportional to V square. Okay. After that, sir, connection. Same thing. Just I'm showing 2 times for more clarity. Sir, M, right? This M is connected over here. Okay, and L to V here, C to here. Okay, after that, sir, this is connected over here. Check it, sir. This entire this is device is coming in parallel or not? The entire device is coming in parallel in the circuit or not? Yes, it is coming in parallel in the circuit only. After that, simply TD we have got it. TC, KC, theta. If you simplify that, theta proportional to V square, non-linear, non-uniform, square law scale. Non-linear, non-uniform, square law scale. Clear? So this is the total discussion regarding what is it here? EMMC as an ammeter, as a voltmeter, as a wattmeter, After that, here, few people are very keen about this, sir. These two are in series, opposition, series aiding. That depends on the connection. No need to worry. Here also, sir, these two are series aiding or series opposing. That depends on the connection. No need to worry. These two are just possibility is there or not. Yes, possibility is there. Enough. That's why EMMC instrument can be used as an ammeter and voltmeter also. Ammeter and voltmeter also. Clear? I told you this point. Again, people are asking in the ammeter or voltmeter, cos phi should not be taken. I have repeated almost 3 times, 4th time saying, sir, cosine phi. Cosine phi is what? Cosine of the angle between voltage parameter and current parameter. But both coils are only in series means in the line current and current only. Cosine phi not there. Here also, sir, entire thing is with respect to parallel. Parallel means voltage. Voltage means only single voltage term, no current term in this. Therefore, cos phi will not be there. That's what the point. Clear, guys? So this is the total discussion regarding, yes, current, voltage, power is measured or not. But here, so DC or AC, don't worry, current is measured. Yes, current is possible. Yes, but after some discussion within half an hour, we are going to conclude all the devices such that EMMC preferred for this, not preferred for this, because so many errors are there. Like that complete discussion I'm going to take. That's it. Before that, here, proportional to this, sir. Therefore, I'm writing directly. What is that? Here. Therefore, EMMC can be used as an ammeter, a voltmeter, as a wattmeter also. Be clear, using only, not preferring. I told you one fun example. I told you, so no, from the 10th floor, can we jump or not? We can jump. That's it I'm saying. But whether we jump or not, what is a drawback, that will be taken later. But I'm explaining only possibilities there or not. We can jump from the aeroplane also. Jumping is, yes, possible, but preferable or not, that depends on the damages what we get, errors what we get. That is I'm going to take. So that's why try to understand my step by step only I'm going. But you people are thinking today's topic, linking about tomorrow's topic and getting tensed. Don't do that. Whatever I'm giving, take that only. Clear? So this is a total discussion regarding EMMC instrument construction, operation, and everything. Right? Including mathematical everything we have taken. Finally, yes, ammeter, voltmeter, and wattmeter. Ammeter, voltmeter, and wattmeter. Right? Right. Whatever I told, those are clear or not. I have not used any word for DC, ammeter and voltmeter, DC or AC. Don't worry. I will be taking later whether we prefer or not, etc. So many drawbacks will be there. Don't worry. But connection is possible or not. Connection is possible or not. Yes, that's what the point. Now, the universal conclusion. Concentrate here. Those who missed yesterday, kindly don't ask the doubts in the today's class. Those who missed means many people left the class after 7:30, etc. Those people don't ask the doubts in this, because you need to watch the video, then only you can talk to me, because I'm going to take the error analysis. Again, error analysis in the PMMC, in the MI, in the EMMC. All together I'm going to take the error analysis. Suppose one instrument has more errors, we don't prefer. One instrument has less errors, we prefer. That is what the conclusion I'm going to give now. That is what the conclusion I'm going to give. Clear? Right. And I told you, I'm repeating this point. No one should ask this question again, because in the ammeter, many connections are possible. One connection I'm showing, other connection not possible, or you try it. Okay. And because series, very simple. Sir, voltmeter, one connection I gave you. Why not other connections? You try it. All rough I gave you, you try it. Okay. Sir, why not this? Why not? All I told you, many are possible. Only one of the connections I'm showing. Only one of the connections I'm showing. Right. Ashish Kumar, how supply voltage is provided, sir? Is it from element or externally? You are missing small thing. Concentrate. Sir, I want to measure current through the load. Current to the load means some supply is to be available or not. Here we connect the ammeter. Okay. Already supply to load, some connection is there. We connect the ammeter. Okay. Suppose, sir, here across the load, I would like to measure the voltage. But across this load, voltage should be there or not? Yes, supply is already available. Now I am connecting the voltmeter. Without giving the supply, how can we have the current flow and all, etc.? No. Suppose, sir, load is there, right? I want to measure power consumed. In order to have the power consumption, supply is to be given or not? Yes, supply is to be given. Okay, now we need to measure the power. How? Means here, one coil is in series, one coil is in parallel. Simple short. One is series and one is in parallel. That's what the point. Right? Supply is given means wherever you are measuring something, a supply should be there. Otherwise, simply see, I'm taking one bulb in my hand. Can you measure the power consumed by that bulb? I'm holding one bulb in my hand. Load, right? Can you measure the power consumed by that load? No, yeah. Supply should be given. It should be in the operation condition. Then only we can measure the corresponding power or current or voltage, etc. Right? Okay, got it. Thank you. Right. dm by d theta is constant. I told you already. What is it? dl by d theta constant. In yesterday's I told you dm by d theta also constant. Today's class also I told you. Why? Change in mutual inductance, change in theta, both will be together, but approximately only. dm by d theta approximately constant. We can say almost constant, no problem. Right. Now, very important question here is, sir, which power we measure? Which power we measure? Average power, that is active power, or reactive power, or apparent power, or instantaneous power, RMS power, etc. etc. Be clear. This is a note, but I'm giving as a question. I'm giving as a question. Here, The power measured, the power measured by a wattmeter, a wattmeter is dash, is dash. Option maximum power, RMS power, average power, instantaneous power. Be clear, always we measure average power only. Always we measure average power only. Why means concentrate. See, DC, suppose I'm talking about power DC. In the DC, always average only. Yes, P average is equal to V into I, means V average into I average. That only I gave you here, DC power. IC into V. Yes, DC supplements average values only. There is no RMS at all. Okay, right. Sir, here people are getting confused. Those who have done with the network theory, they know this. But those who are not done with the network theory, don't worry. Okay. Some people told active power, some people told RMS power, some people told average power. See, people are getting confused. Like, sir, PAC is equal to D, which power? I'll tell you. So, what is the formula? VRMS, IRMS, and cos phi. Sir, RMS is there. RMS is there means simply RMS power. No, yeah. This is also average power only. Those who are done with the network theory in the AC circuit analysis, in the power derivation of resistor or inductor or capacitor or RL or RC or RLC, etc., we take this entire thing. This is the equation for average power only. In our practical application, there is no question of RMS power existence at all. Yes? And maximum power we can calculate mathematically, and average power only we calculate. Average power only we cannot. Instantaneous power also we cannot. That's why our wattmeter measures which power? This power. What is this formula? VRMS is there, sir, IRMS is there, therefore PRMS. No, P average only. P average only. This is what the actual point. So that's why always, whatever the question you take, power measurement is by the device means automatically average power only. Automatically average power only. Right? Okay. With all these introductions, now I'm taking with all these entire conclusions and small introduction to the topic, etc. Now I'm taking error analysis. Sir, in the instruments, generally, which type of errors are possible? Already you've taken static, that is okay. In the operation point of view, sir, the pointer is moving like this, means frictional error will be there. Okay, as a supply is given means due to the continuous supply, temperature may be rise, therefore temperature errors also may be there. And AC supply is also given, therefore frequency errors also may be there. As it is a magnetic system, hysteresis errors will be there. Okay, and definitely as we are operating in the practical world, external field errors also will be there. External effects also will be there. That's why these errors are generally common. I'm not talking about parallax error, etc. Those are we have taken in the operation point of view, which are the general errors possible. General errors possible. That's what during the operation point of view, etc. I'm taking. Right? That is here. So errors in PMMC, MI, and EMMC. Errors in PMMC, MI, and EMMC. Okay. What are the errors generally present? Frictional. Why? Moving objects are there. Friction will be there. Current is flowing through the coil. Temperature will be raised. Frequency errors means AC supply is given. AC supply means frequency. Yes, you can. Hysteresis error means magnetic structure, means definitely hysteresis errors are generally possible. Stray magnetic field errors automatically. Stray magnetic field means what? What is that? If you operate in the practical world, external magnetic fields disturbs the internal magnetic field, automatically stray means external. All these are commonly present. But our duty is to analyze that PMMC, is it more or less or medium, etc. MI more or less, EMMC more, like that. We need to compare each and every instrument. But before starting, I'm giving you whatever we have spent day before yesterday and today till now, everything will be revised. Everything will be revised with my topic. One thing, if you understand up to this everything, my next topic will be clear. That's why vice versa. Topic is clear, this topic is easy. If this topic is clear, earlier topics will be like just a revision point of view. One thing. Second thing, be clear, guys, be clear. Now I'm going to compare one to one. Suppose this error is more, we don't prefer. In this error is more, we don't prefer. In this error is less, we prefer. In that way, we are going to give the conclusion. One thing. One second. Concentrate, guys. Kindly respond. Sir, while I complete almost half an hour to 40 minutes, I will take, means up to the break time, I will take this topic only. Give me the time. Don't ask the questions while explaining, because after completion of all, you can understand one by one clearly, step by step. Means I will explain this. I will explain like this, step by step. I'll be going. So kindly 45 minutes topic. I'm actually the shortcut I can give you. Shortcut I can give you, but concept I'm giving. After that, simple logic you can remember. And I'm requesting, you can ask the doubts, but not now. Not now while the topic is going on. You will be missing the topic. Definitely wrong thoughts will be there. With respect to these topics, generally, that's why I'll clarify all the doubts. Be clear. Before going to that, already I gave this entire thing, just I'm giving as a note. So what is it? Permanent magnetic field means constant magnetic field, unidirectional magnetic field, strong magnetic field. You know that. Electromagnetic field means varies with the supply, and dependent magnetic field. So dependent magnetic field means automatically weak in nature compared to permanent magnet. Okay, first friction. Sir, frictional error comes into picture. Frictional error comes into picture with the body movement or without the body movement. Means body, don't answer. I'll question, I'll answer. Sir, body is static. Does it get any friction? No, the body is under motion. Then friction comes into picture. Okay, so therefore friction comes into picture when the body is under motion. Okay, sir, when do we get the body motion? When do we get the body motion? Means otherwise the body motion depends on which one? The applied force on it, as well as body weight also. So therefore indirectly what is it here? Body weight and applied force, isn't it, will decide the motion. That motion will give the friction. So therefore frictional error is indirectly depending on which one here? Applied force and weight of the object. Okay, sir, applied force is more. Bearings are there here. Applied force is more. It will rotate with more revolutions or less revolution. Means applied force is more, means more revolutions. Means what is it? If the applied force is more, it will be overcoming the friction and rotating properly. Therefore frictional error will be less. I'm coming again. If I apply the more force on the moving body in our measuring instrument where bearings are provided, if more force is applied, more rotation. If it is getting more rotation, means it is overcoming the friction, not eliminating, overcoming. Therefore friction error will be less. Next, second thing, sir, this moving body, entire spindle, spring, etc., total thing, if moving body weight is large friction, large error. Moving body weight is less friction, less error. This is what the total analysis. Now I'm going to show one by one. Sir, frictional error. How the frictional error comes into picture? Sir, torque is strong, that is force is strong. Obviously frictional is less. Means the what I told you, if I apply the more force, what happens, sir? The body gets displaced. More. So therefore friction will be less. Frictional error also will be less. One first point. Second thing, sir, if weight of the moving object is less, WT means weight, weight of the moving object is less, lightweight body, less friction and less frictional error. Means, sir, we want which one? Less frictional error only we want. We want which one? Yeah? Less frictional error. Okay, sir. How do we get that less frictional error? Means with the strong force, with the less weight. That's why I'm combining. So torque to the weight ratio, very, 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 very important. GATE, ESC and interview of any exam, very, very important. Torque to the weight ratio I'm taking. Sir, torque is strong. Torque is strong. What is it? Friction is less. So torque is strong, frictional error is less. In the same way, weight is less. What is it? Frictional error is further less. Okay. So therefore, numerator is more, denominator is less. What is it? Ratio will be high. Therefore, what we can say indirectly? High torque to the weight ratio. High torque to the weight ratio will give less frictional errors or more frictional errors means less frictional errors. I'm coming again. Frictional error comes with torque, comes with weight of the moving object also. Torque is strong, frictional error is less. Weight is less, frictional error is less. That's why I'm taking the ratio. Why to take individually? Yes, I'm combining those two. That's it. Therefore, torque to the weight ratio. Torque more, frictional error is less. Weight less, frictional error is less. Therefore, numerator more, weight is denominator is less. So therefore, ratio numerator more, denominator less means ratio will be here. That's why high torque to the weight ratio gives less frictional error. That will I'm giving here. Therefore, high torque to the weight ratio gives less frictional error. This is very, 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 very popular objective question directly in the ESC exam. GATE point of view, some other question will be seen that later. In the ESC objective point of view, high torque to the weight ratio of the instrument gives dash error. Dash frictional error means less frictional error. Right, sir. Now let us start the topic. What is it? See, I'm taking PMMC and MI comparison. For example, PMMC permanent, MI electromagnet. Now tell me, in which case the torque is strong torque? In which case the torque is strong torque? In which case the torque is strong? In which case the torque? I'm not asking you, don't respond it to you. Right? I will ask the question and I will answer. Otherwise, you will be missing. You will be missing. That's why you are getting one doubt. Who is this? Nitesh Kumar. Right. See, what is it here? Sir, permanent magnet strong. Moving an electromagnet weak. Yes or no? And that too, you are missing small thing. This means if means this is what the condition we require. If torque is strong, people are asking, so how the torque is strong? I'm taking analysis here. If the torque is strong, friction error is less. If the weight is less, frictional error is less. I'm giving. After that, this is the ratio. Now, in order to get the less frictional error, what we need to have? High torque to the weight ratio is required. That is what the conclusion. Now let us see some. So permanent magnet, strong torque. MI electromagnet, weak torque. Okay, and sir, PMMC or MI or EMMC, weight of the moving object will be almost same, not very different. Why? All the devices are portable devices, carrying devices only. That's why. What is that? Technically, moving object is spindle, spring, coil, or iron piece, etc. Almost same. That's why weight is almost same. We can take it as same, no problem. Sir, torque to the weight ratio, torque to the weight ratio is more in PMMC, less in MI. Therefore, in which device frictional error is more means MI device frictional error is more than the PMMC instrument. In MI instrument, the frictional errors are more than the PMMC. Why? I'm coming again. Sir, torque is strong because permanent, strong torque. And MI EM, electromagnet, weak, but weight is almost same. We can take it for granted. It is not the assumption. We can take it for granted. Weight of the moving, because all are portable, almost same weight. But no, very micron weight may be different, neglected. Okay, weight is same. That's why denominator is same. Numerator more, ratio more. Numerator less, ratio less. Numerator more, ratio more. Numerator less, ratio less. So automatically, what is that here? MI instrument has frictional error more than the PMMC device. Why? I told you here. High torque to the weight ratio, less frictional error. Less torque to the weight ratio, more frictional error. That's not the point. Right? This I'm giving clearly. Check it here. See, permanent magnet moving coil instrument, torque to the weight ratio. I have underlined the weight, same. Torque is strong. What is that? Ratio is high. Torque is weak. Ratio. Why? I have given electromagnet word also. Electromagnet word also permanent magnet. Therefore, what we can write? Torque to the weight ratio in PMMC is greater than, 1 second. Here is more than MI, is more than MI. Therefore, frictional error is more in MI than PMMC. Therefore, frictional error will be more in MI than PMMC. Why? Torque to the weight ratio is like that. This is one thing. Second thing, now 100% confusion will be there. Kindly concentrate. Now I'm taking MI instrument, EMMC instrument. Okay. In this electromagnet, in this also electromagnet. Okay. Torque to the weight ratio. Torque to the weight ratio. All I told you, weight is almost same. Now tell me which is strong and which is weak. It means the point here is people are answering like this, sir. People are generally justifying like this, sir. 2 coils are there, so therefore strong. 1 coil is there, therefore weak. People are writing like this. No. Be clear. Actually speaking, if we compare these two, MI strong, EMMC weak. Why? Be clear, guys. Here, MI is strong. You guys say correct. Abhishek Kumar Singh, EMMC, is it strong or weak? You are not given. No problem. What you are missing, concentrate, guys. Concentrate. Sir, 2 coils are there, correct. 1 coil is there, correct. But what you are missing, no? Sir, in these 2 coils are 2 electromagnets only. Coil gets magnetism, it's electromagnet. Therefore, in this EMMC, 2 dependent magnets are there. In this EMMC, 2 weak magnet, electromagnet weak only. 2 weak magnets are there. What will be the resultant? Further weak. But in the moving iron, yes, electromagnet only, but only 1 coil is there. That is the reason why only 1 coil weak. Here, 2 coils are weak. I'm coming in 1 coil electromagnet which is weak, which is dependent. But here, 2 coils electromagnet which are double weak, double dependency. So therefore, which is strong torque here? MI torque is stronger than EMF. Therefore, what is it? Ratio is high, ratio is low. Therefore, what is it here? EMMC greater than MI. Which one here? Frictional errors. Frictional errors are more in EMMC. What is it? Compared to the MI instrument. Right? I'm repeatedly saying this. This is generally doubt for many of the people. Definitely. That's why I'm repeating this point again. Sir, EMMC 2 coils strong? No. EMMC 2 coils, 2 are weak coils. Because electron and electron. MI, only 1 coil, 1 is weak. Here 1 is weak. Here 2 are weak. The 2 dependently operating. Weak and weak, dependently combination. Automatically resultant is further weak. Automatically we can say yes. MI is more, what MI is more torque to the weight ratio than the EMMC. Therefore, error will be. This is what the complete relation related to PMMC, MI, and EMMC. Clear? And people are asking this, sir, in the MI, iron piece is weight, no, and in the EMMC, moving coil, no. That's why I told you, approximately weight is assumed as constant, you can take it for granted. It is not the random assumption. You can take it for granted because almost all the instruments, moving objects are almost similar only. That's why even though here Mi iron is there, PMMC coil is there, etc. Yes, definitely. What is it here? Little bit weight difference will be there, but that is very negligibly small. Neglect. That's why we are concentrating only on torque equation. We are concentrating only on torque equation. Now I'm showing this. Concentrate. EMMC and Mi. Two are electromagnets only. Torque is weak than the Mi torque. Weight is same. Sir, torque to the weight ratio is less in EMMC than Mi. Okay. Therefore, what we can say here? Yeah, weight of the moving object is constant error, not required. Simply, what is it? Frictional error is more in EMMC than Mi. Frictional error is more in EMMC than Mi. Now, with all these discussions, what we can conclude, concentrate. Sir, frictional error, EMMC more than Mi than PMMC. That is nothing but torque to the weight ratio is more in this, medium in this, less in this. That's what the complete conclusion with respect to torque to the weight ratio concept, that is frictional error concept. That's why I told you with very lengthy topic. But if you understand this, the thing will be done very easily. We can do very easily. We can do. What is that? Sir, I'm coming again. Frictional error is more in EMMC than Mi. Again, Mi is more than the PMMC. That's what. This is the complete ratio. I'm coming again. In this, weight is treated as constant, approximately constant, no problem. Suppose in the question, weight is given differently, follow that. But universally, yes, this is the rule. Okay, and torque to the weight ratio is strong in PMMC, weak in Mi, weaker in EMMC. That's what the point. But don't think like, sir, EMMC very high weight, not like that. Mi, PMMC error is some 0.2%. Mi error 0.5%. And EMMC, that is what the last, but don't say that, sir, EMMC, don't use. No, what is it here? Simply comparatively more, but don't think like, sir, 99% error is not like that. Comparatively, little bit more error will be available. Clear? If you understand this, all other next topics are very simple. Clear? Right. Next one. 1 second. So temperature point of view. What is a temperature point of view? Very important thing is the temperature point of view. We need to concentrate one thing. Right, sir. Temperature error. Very simple idea. Same logic here. Same logic. Whatever the logic we have prepared, same thing. Sir, one coil. Sir, one coil, two coils. Is or no? One, sir, permanent magnet, one coil, strong permanent magnet, weak electromagnet, weaker electromagnet. That's what the thing. Same discussion. Concentrate here. So temperature error. Sir, EMMC more than Mi than PMC. Sir, why? PMMC reads always I average. Come on, guys. PMMC reads always I average. But Mi, I average also IRMS. I'm writing. Now tell me, RMS value is more or average value is more? RMS value is more or average value is more? Everyone concentrate. RMS value is more. Why? RMS value is equal to average value into 1.11. That you study in the network theory, power system, machines, and everywhere. In our discussion also, in the electronic measurements, I will repeat that again on it. In the electronic measurement, we are going to use this type of formula. But as an electrical engineer, as an instrumentation engineer, you should know this relation. RMS value is equal to average value into 1.11. Clear? So therefore, sir, I average PMMC at any cost average value. But MI average value into 1.11 equivalent value is measured. Sir, more current. I think everyone knows that current is more, automatically temperature effect is more. Everyone knows that more current is there, more temperature effect. More temperature effect is there, more temperature losses will be there. So that's why, what is it here? MI more than the PMMC. MI more than the PMMC. One logic. Second thing, sir, how can you say EMMC means EMMC also RMS, average also? Sir, RMS both are same. No, yes, but small change here, sir. In this, only one coil carries the RMS current. In this, two coils are carrying the RMS current. In this, only in one coil temperature error will be there. In this, two coils temperature will means where do we have more temperature dependency? Automatically EMMC only. EMMC only. That is the reason why, yes, we need to go for EMMC more. Again, simple logic. EMMC two coils, two temperature problems. MI only one coil, one temperature. PMC anyway, one coil but average value, so less only. This is temperature error. Okay, next. Frequency error. Sir, frequency error. Same logic. PMMC DC 0. MI one coil. One coil means 2 pi FL will be there. Only one frequency term. But EMMC 1 2 pi FL, second 2 pi FL. Why? Two coils are there, two reactants will be there, two frequency effects will be there. So automatically, yes, EMMC instrument has more frequency dependency, and MI has less frequency dependency. PMMC is independent. That's why error will be more in EMMC, less in MI, further less in PMMC. Okay, right. Next, fourth one. What is that? Hysteresis error. Very, very simple. First of all, directly we can say PMMC. What is it here? Again, PMMC is less. Already I told you. DC I have written means zero frequency errors only. No need to mention. DC means frequency. 0 is less than 1. 1 is less than 2, 3. Like that, the number I gave. Okay, come to this. Sir, hysteresis. Be careful here. In PMMC means DC. In DC, do you get hysteresis concept? In DC, do you get hysteresis loss? Because in the DC, frequency is not there. Frequency is not there. Therefore, hysteresis errors are itself is frequency dependent. Frequency based only, hysteresis errors will be there. So that's why hysteresis error means DC. No hysteresis error. No hysteresis error. Okay, next one, very, very important. Sir, MI, which is used, iron piece is used. Iron piece is the ferromagnetic material. Ferro, more magnetization. Automatically, more energy stored will be there. More hysteresis loss will be there. Therefore, what is it here? More hysteresis error. More hysteresis error. But sir, EMMC, sir, EMMC means, what is that? Electromagnet moving coil instrument, right? Now I'm going back to the starting topic. What is that? Sir, I have shown with the box type structure here. Yes or no? Right? These are coils, I told you. These are coils. Generally, construction itself is, be clear guys, in this, right? We are using, who is using? Manufacturer only using. Which coils means in the EMMC, whatever the coils we use, those are air-cored coils. Whatever the EMMC or whatever the dynamometer type instrument you used in your laboratory, in all those devices, air-cored coils are used. Why means, sir, this is error, more error. We cannot change this condition. It is also more than this. We cannot change this condition. and frictional error also more than this. That depends on the conceptual part. That's why what they thought is, okay, let us try to get the less error possibly. How? Means the coil is without the core, that is air cooled coil. So air cooled coil is there. What is the hysteresis error here? Hysteresis error is less. Why? Air cooled. Air cooled means mu r is equal to 1. Air cooled means mu r is equal to 1. Why? Air relative permeability is 1. Iron mu r is far greater than 1. So where you have more energy storing capability, Mi only. That's why in this case the Mi instrument has more error than the EMMC, than the PMC. Anyway, no hysteresis error at all. Right? Now, next one. Sir, stray magnetic field errors. Very simple. Sir, stray magnetic field means, I'm coming here. Sir, stray means what? External. Stray means what? External. So my question is, concentrate. PMMC, MI, EMMC, in which instrument the corresponding stray magnetic field errors will be more? That's what the question. Concentrate here. Sir, internal PMMC, right? Be clear with the terminology. Air cooled coils, sir, loss is zero. Ideally, loss is zero. But practically, air mu r is equal to 1. That's what I told you just now. Mu r is equal to 1 means very negligibly small, we can say. Or if you want to write no hysteresis, we can write. But general terminology is less hysteresis we can take. Very simple. People are asking me to repeat this. Very simple here. Hysteresis, concentrate. Here, I told this topic when I was explaining hysteresis. Right, sir. In which case hysteresis error is more? In first case, hysteresis error is more. Why? More residual magnetism. More residual magnetism means more storing phenomena. Over. Iron piece, ferromagnetic metal, it will store more error. Air. So automatically, what is it here? Air means very less hysteresis error because air has the less energy storing because mu r equal to just 1. Mu r is equal to just 1. That's why very less we can say. We can neglect it, no problem. Okay, I have repeated. Right, I have explained. Right, two people asked that, Tulasi and Shravani, and one more person. Right, okay. Right. PMMC, okay. PMMC, DC. PMMC is applicable only for DC. DC frequency is 0. Frequency is 0. Hysteresis error. Actually, you will study in the missions. Hysteresis error proportional to frequency. Frequency is 0. Error will be 0. That's why in the PMMC, hysteresis error will be 0. Clear? Okay. Now, coming to stray magnetic field. Here, people are saying that, sir, how the stray magnetic field error means? Very simple. Very simple. Sir, stray magnetic field errors will be more. Simple logic. Yeah, simple logic. External side, from external side on the internal side, internal magnetic field, that is called as stray, means effect of the external magnetic field on the internal magnetic field, that is called as stray magnetic field effect. Okay, my question is, sir, internally PMMC device I'm taking, strong magnet is there. Outside effect will be less or more? Outside effect will be less or more? Definitely less. Why? If you are strong internally, effect from outside will be less. Like that. If you want to answer stray magnetic field errors, you need to go back to the corresponding, which is frictional error. Sir, strong torque. Here, weak torque. Here, weaker torque. Double arrow I'm giving. Sir, internally strong, effect from the outside is less. Internally weak, effect from the outside is more. Internally weaker, effect from the outside will be more and more. That's why with this entire concept, in which device we have more and more. What is it here? stray magnetic field errors will be there means concentrate here. Here, sir, error due to external magnetic field. Sir, PMMC, strong internal magnetic field. So low stray magnetic field. MI, right? Weak internal magnetic field. So error will be more. EMMC, further weak internal magnetic field. Therefore, error will be more. Right? You know to understand, small fun thing I'm giving, concentrate. Sir, generally, suppose any one holiday is there, no, on that holiday, before the holiday, what you think? I will prepare tomorrow. I will prepare tomorrow. Subject. Okay, you want to prepare. The moment you are starting the preparation, your friend came to your home. Normally, your friend came to your home or room, etc. And he will say that, come on, let us go to movie. Let us go to movie. What does it mean? Instantly, without any second thought, we'll go to the movie. After going and coming back from the movie, what we say? Yes, because of you only my time is wasted. Friendship, yes, we can say. Therefore, because of that only, because of you only my time is wasted. So my question is, okay, your friend is asking you, okay, that is external effect. If you are internally strong, says that I don't want to watch movie. If you're strong internally, does your friend affect your internal case? No. Means the moment your friend is asking means you are going to the movie means internally you are weak. Means okay, internally also, right? Movie related things, internally you are also thinking to go to the movie. Means internally also you are interested. Means internally you are weak. Internally you are weak. Therefore, it looks like, what is it? Friend effect is more. Yes, when you are internally weak, effect from outside will be more and more and more will be there. That is a simple example of this entire concept. Clear? Right? So that's why, sir, PMMC, internally strong, error will be more. MI, weak, sorry, internally strong, error will be less. And MI, weak, error will be more. EMMC, weaker internal magnetic field, error will be very, very, very high. And people are asking this, doubt continuously. Concentrate. Sir, hysteresis error is proportional to frequency. Hysteresis error also depends on magnetization. That's why iron is best ferromagnetic material. That's why simply the iron content structure definitely has more storage phenomenon. More storage phenomenon means more hysteresis error. After that, in the EMMC, as it is air cored coil, because it is no iron piece, nothing. So therefore, air cored coils less error. I told you. PMMC, DC, anyway, no hysteresis. But in the PMMC, people are saying that magnetization will be there. No, sir. Magnet is there. No. Yes, that is simply stored energy will be there. That is also very, 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 very smaller only. No need to it. That's why based on the nature of the hysteresis concept, that is proportional to frequency and all, we can say that. Otherwise, suppose, sir, operation based, if I want to say, storage point of, if I want to say, sir, PMMC also storage energy will be there, stored energy will be there. Based on the stored energy, little bit hysteresis will be there. But hysteresis error is 0 or something else is present means supply based. We can give that based on the supply base we are giving this. That is what the PMMC structure. Right? Right. This is the total discussion regarding error analysis of all the three devices. Now, finally, whatever this one, that one, small doubts are there. To many people, all the doubts will be clarified in 2-3 minutes of time. Okay, right. And before going to that, I'm revising entire thing. So frequency, two coils are there. Two coils, F1, F2, both are there. Nothing but what is it? L1, L2, both are there. 2 pi FL1, 2 pi FL2. Two frequencies here, only one frequency dependency. Therefore, frequency error is more in this. That's why I told also. That's why I'm explaining What is that? Listen carefully. EMMC 2 coils, take it. MI 1 coil, take it. PMMC DC. Based on that, we can define all the corresponding errors. So finally, sir, conclusion. EMMC has more errors than MI, and MI has more errors than PMMC. This is what the complete universal conclusion. Complete universal conclusion. Okay. Now, with all these conclusion, with all these error analysis, now I'm taking this one. Sir, advantages of PMMC. Linear scale. Torque to the weight ratio is high. With all this conclusion I'm giving. Less errors, obviously. High accuracy. Why? Errors are less. The measured value is close to the true value. High accuracy. And if I want to write, I can write one more thing also. What is it? High sensitivity also I can write. High sensitivity also I can write. Clear? High sensitivity. Okay. Next. So what is the disadvantage? Not applicable for AC. One and only one major disadvantage is not applicable for AC. Suppose, sir, if I give all these advantages before giving this error analysis, do you understand all this? Definitely no. Sir, what is error? What is high accuracy? We don't know. That is the reason why I have taken all the three devices clearly one by one. After that, now I'm giving the corresponding error analysis. Clear? Now, sir, come to MI. Very simple, sir. Advantage can be used for both DC and AC. But drawback is non-linear, non-uniform, square law scale. Errors are more than PMMC. Errors are more than, obviously, more than PMMC. Okay, next. So EMMC. Sir, can be used for both DC and AC is advantage. I'm giving complete summary. Can be used for measurement of current, voltage, and power, and hysteresis error is less. Why means specifically I'm mentioning this because all errors are more except hysteresis. That's why I'm specially mentioning hysteresis error is less. After that, very, very, very important conclusion is be careful, guys. While I was explaining, I told this. What is it? Sir, non-linear, non-uniform, square law. Theta proportional to I square ammeter, theta proportional to V square voltmeter. That's why square law scale will be there. Square law scale will be there. That is when square law scale will be there. That is when current and voltage measurement already told you theta proportional to I square, theta proportional to V square. So IV. Which scale? Square law scale. But so just non-linear, just non-uniform means cosine based non-linear, cos phi based AC power measurement. Clear? Right. Next. Sir, errors are more than MI and PMC except this one. Except this one, all errors are more than MI and PMMC only. This is the complete conclusion of the all three devices. Okay. Now, with all these things, now I'm giving universal conclusion. This is not there in the textbooks. Kindly concentrate. Kindly. Why I'm mentioning like this means you can concentrate more. Sir, first one. Sir, sir, PMMC I'm taking here. Kindly wait for 2 more minutes to conclude this entire three devices. So PMMC. Okay. Right. I'm taking. Sir, MI. Sir, PMMC is applicable only for DC. Already we have taken. Sir, in DC again, current measurement is there, voltage measurement is also there. Okay. Sir, in MI, DC is there and AC is also there. Sir, in DC again, current measurement, voltage measurement. In DC, current measurement and voltage measurement. Okay, coming to EMMC. Sir, DC applicable as well as AC applicable. Sir, in DC again, three things are there: current measurement, voltage measurement, power measurement. Current, voltage, power measurement. Whatever the thing we have taken yesterday and basics day before yesterday and today so far, complete conclusion is this. But be clear, not completed. Sir, DC, that to PMMC, average only. Sir, DC, average. AC, RMS. AC is RMS. Sir, EMMC also, DC, average, average. And AC current, RMS, RMS. But already told you, power will be average only. Either DC or AC, power will be average only. But both are not same. Here, DC means V average into I average. AC means VRMS into IRMS into cos phi. Okay, now come back. Sir, which scale? DC, PMMC linear scale, MI square law scale, and EMMC current and voltage square law. Current and voltage square law. AC power non-linear, no, we don't need to mention. That will be formula based non-linear. Now, I'm asking just three questions. No need to answer, just I will answer that. Sir, suppose you want to measure DC current. Come on here. You want to measure DC current and DC voltage. Which devices are there with us? PMMC, MI, as well as EMMC. Three devices are there. Now, based on the complete analysis what we have taken so far, which device we prefer? Don't answer, I will tell you. Which device we prefer means PMMC errors are less. Therefore, we prefer. For which one? DC current and voltage measurement. Sir, DC current and voltage, MI is also there. Do you prefer without this DC? Without this PMMC? No, because PMMC gives less error than the MI. Therefore, we don't prefer. That's why in your laboratory, MI, you preferred only in AC machines lab. Why means? If you use MI for DC, it gives more error. If it gives more error as an operator, are we ready to prefer? Definitely no. I hope it is clear. Next, coming to AC current and AC voltage means RMS current and PMMC anyway not there. Sir, now concentrate. Sir, AC current measurement, AC voltage measurement. MI is there, EMMC also there. Okay, before going to that, sir, DC current and voltage, PMMC is having less errors definitely. MI is more error, we don't prefer. Sir, what about this one? Obviously don't prefer. Why? Why? EMMC has further more errors than MI and PMMC. Are you ready to prefer here? Never. Okay, next. Sir, AC current and AC voltage. MI is there, EMMC also there. But if you compare these two, MI is more error than EMMC is more error than MI. Therefore, we don't prefer this. We prefer this only. Finally, EMMC, DC power management, AC power. Do you have any other device which measures the power? No. Ultimately, we prefer. That is the reason why I concentrated PMMC meant for DC measurements practically. Current and voltage. MI is meant for AC current and voltage measurements practically. EMMC is generally meant for power measurement only. That's why in your laboratory, if the device is given like WDC or WAC, here 4 terminals are free only. You want to connect as an ammeter, you can connect, but it will give more error. That's why we don't use it. Why? PMMC is best. DC current and voltage, PMMC is best. AC current and voltage, MI is best. Why do you go for wattmeter? That is EMMC as a current and voltage? No, that is the reason why. What we have taken here, sir, concentrate here. Is it possible or not possible? Yes, possible. But which is preferred means this one. That's why be clear. Either in this page or in this page. Very, very, very important thing is tick mark indicates. Don't say used here. If you say used, total 3 days of session will be waste. That's why tick mark indicates prefer. What is the difference between using and preferring? Every time bring the 10th floor to jumping example. Yes or no? We can jump, that is using, but we don't prefer, that is preference. And here, cross mark indicates not prefer. Now, finally, I'm asking 3 questions. I'll answer this. Then all doubts will be clarified. We'll go for the break. Just 2 minutes. DC current and voltage can be measured by PMMC, MI, EMMC, but preferred is PMMC. AC current and voltage is measured by MI and EMMC, but preferred is MI. Power is measured by EMMC only, so preferred is EMMC only. This is what the complete conclusion of all the 3 devices, step by step, everything I have taken. But in this EMMC, one thing I have not taken, right? I told you I will take later. I told you, sir, why we have taken 2 current coil parts? Very simple, yeah, very simple. See, one current coil part, one current coil part, one moving coil here. Suppose if I using only one current coil, one moving coil, sir, where do we get better mutual? Where do we get better mutual is this coil is getting flux linking only from one direction, but here both directions. So where do we get better mutual means if you use 2 parts of the coil only for getting the best mutual effect. Yes, 2 parts of the coils are used. 2 parts of the coils are used. One thing. Immediately the moment I say this, people are saying that, sir, why not 3 parts then? Why not 4 parts then? If you want to go for, you can go for n parts also, but that becomes complex construction, cost will be increased, etc. That's why experimentally proved and best one is 2 parts of the current coil is for getting the better mutual effect. Other than that, nothing is there. Now this is the complete conclusion of all the 3 devices in detail, step by step I have taken. Okay, now I'm giving the break. After the break, let us come back and let us solve the various possible numerical questions in the PMMC, MI and EMMC. Then we'll go for the next device. Okay, take the break and come back. Come back. Harshita, okay. Actually, due to some problem, it has been delayed. I think only today it got delayed. Right? Notes are video uploading. Otherwise, he uploading the correct time only. Yeah, only today. Actually, these days everyone is having the problem with COVID and family members, etc. So suddenly something might happen. No, that's what it got delayed. Right? It will be only for today. Only today it got delayed. It seems because a few people message me. Only today, because actually openly saying his family members are suffering from COVID. Actually, by this time everything might be okay, but some problem. Right? Don't worry. Situation is like that. We cannot do. Right? This is the total discussion. I hope whatever the connection problem, sir, why EMMC ammeter like this only, like that only, etc. I told you, no, we don't prefer because of errors more. That's why finally we are using only EMMC instrument. Right. Vinitha, I gave my number. You can contact to WhatsApp. Right? If any doubt is there, you can send me, no problem. Right. Why PMMC has high sensitivity, sir? Yesterday I told you in the PMMC. Kindly go back to that notes and get it. Right. Okay. Now let us have some questions. Right. PMMC questions, MA questions, and EMS all together questions will solve. This is the best conceptual question. Very, very, very important. That is the reason why PMMC topic, some question. MA topic, some questions. EMMC topic, some other questions. After that, all questions together means entire three instruments will be revised. That's what the main idea. Right. See, extension of range of EMMC is not there. No need to worry. Right? Not there, no need to worry. In the syllabus, it is not there. Don't worry. Right, sir. PMMC instrument, that is not central spring, it is control spring. The control spring stiffness and the strength of the magnet decrease by 0.04% and 0.02% respectively due to a rise in temperature by 1 degree centigrade. With a rise in temperature of 10 degrees centigrade, the instrument reading will be dash. The instrument reading will be dash. This is what the question. Right, sir. Very, very important point. Kindly consider. I'll explain the entire topic. Don't try to answer this question especially because it is complicated one. Small technical logic is there. So what is that? Spring stiffness and strength of the magnet decrease. So I'm taking first stiffness, okay, and strength of the magnet. Okay, right. So decreases by 0.04% and 0.02% respectively. So therefore 0.04% reduction, 0.02% reduction. He only has given reduced, decreased. Okay. due to a rise in temperature of 1 degree centigrade. So therefore, this is what happened with 1 degree rise in temperature. With 1 degree rise in temperature. Am I clear? Okay, sir. Now, sir, what he is asking, with a rise in temperature of 10 degrees centigrade, the instrument reading will be, with a rise in temperature of 10 degrees centigrade, the instrument will dash, means how much temperature? 10 degrees. That which device? PMMC. Okay, right, sir. Here, for 10 degrees centigrade rise, what will be there? 1 degree this much, 10 degrees automatically, yes, multiplied by 10. How much? 0.4% reduction. 0.4% reduction. Right? Clear? 1 degree, 0.04, 10 degrees automatically. What is it here? 0.4. 0.04 into 10. That is 0.4. Okay? Right. Next one. Sir. Sir, stiffness of the spring is disturbed. Stiffness of the spring is disturbed. Then stiffness of the spring is disturbed. Then which will be disturbed? TC, because controlling torque. Strength of the magnet means TD. Okay, right. So stiffness is disturbed means not proper contraction expansion. TC will be reduced. Disturbed means reduced. TC reduces by 0.4. TD, sorry, 1 second. 1 second, 1 second, 1 second. 2, 2, 2, 0.2. 0.04. Okay, right. Here, 0.2%. Yes, 0.2. Okay, after that. Sir, here doubt will be there. So deflecting torque is reduced. Deflecting torque is reduced automatically. The deflection theta will be reduced. Sir, why? The TD means moving torque. This moving torque is reduced means automatically the pointer will make less displacement. So therefore, theta reduces by 0.2%. Theta reduces by 0.2%. Okay, sir. TC is reduced. Here, small doubt, I am doing the same thing, whether it is correct or not. Let us verify. Sir, what people are thinking, so TC proportional to theta, TC reduces, theta reduces. Many people, generally in the class, many people says this only. Okay, let me explain. Here. TC reduces, theta reduces by 0.4. Sir, theta reduced. So automatically combined effect is theta reduces by how much here? 0.6%. So theta reduces by 0.6 means reading reduces by 0.6%. See the options, right? Decreases by 0.6%. Option is there. What do we do in the examination hall? Okay, tick mark, and you will get the mark counting with 34, 35, 40 marks, 50 marks, etc. You'll count it. But is it correct or wrong? It is wrong. It is wrong. But why I have taken wrong thing? Why I have taken wrong thing? To show that if you do the small mistake, whatever the answer we are getting, that answer will be there in out of 4 options. 99% they will give. Means if you are doing small mistake, the answer will be there. No, that will be there in the options. Sir, where it is missed means concentrate here. Sir, TC proportional to theta only, but here TC reduces, theta will not be reduced. Why? TC means which one here? Opposing force. You're missing something. TC, opposing force is reduced. Suppose, kindly look at me. This is TD. This is TC. Okay. TC is reduced means it will be making more movement. Or conceptually we can say TC means opposing force. TC means opposing force. Sir, opposing force is reduced. If the opposing force is reduced, movement of the body will be increased or decreased? Increased. That is what? Very, 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 very important point here. Here. What is it here? It will not be decreased. It will be increased. Okay, now, sir, 0.4 incremental, 0.22 decremental. Then the resultant value will be increased. How much? Sir, resultant value 0.4 incremental, 0.2 decremental. Combination is 0.2%. Reading is increased by 0.2%. This is not the answer. With this complete PMMC operation, what is it? TD, TC, all operations will be clear. So answer here is yes, this one increases by 0.2. Otherwise, if you're taking the wrong thing, answer is there. So be clear, it is not correct. Step by step. That's why I told you while I was explaining also, TC means TC name itself indicates it is TC name itself indicates which one here? Opposing force. I told you clearly. That's why be clear with the terminology. Bharat Kempeller, how dare you to say this? So you're putting us unnecessary doubts by explaining wrong method first always, right? That is a way of explaining. If you're having the problem, don't listen the wrong method. Okay? I know how to explain and all. You might be talented. You might be very talented, I think, right? But other people also should understand the method, right? If you do the small mistake, what is the problem? You should know. Not you means other people, you know already, right? Other people should know because negative marking is there. That's why I know which must be taken first, which must be taken later. You don't need to say, right? Right. So this is what the thing. Now, here people are having the doubt here, sir, TC and TD, how you are getting means simple logic here. Spring stiffness. Stiffness means related to TC directly. Strength of the magnet related to TD directly. That is what we are taking. That's it. Clear? Right. Now, let me take one more question. Sir, 1 second. Yeah, here. The deflection angle of the pointer of an ideal moving iron ammeter is 20 degrees for 1 ampere DC current. If a current of 3 sin 314 T amperes is passed through ammeter, then the deflection angle is dash. This type of question already we have done. I gave the homework question also. Right. Try this. Different answers from different people. Right, very simple. Sir, deflection angle of a moving iron ammeter. Concentrate. Which device? Moving iron. Moving iron means which one here? Theta proportional to I square. First you have to write that. Theta proportional to I square. After that, what we can write? Theta 2 by theta 1 is equal to I2 square by I1 square. I2 square by I1 square. Sir, be clear with the terminology here. Sir, theta 2, we don't know. Sir, theta 1, how much? Theta 1 is 20 degrees. 20. Sir, what is I2? Here you have to concentrate. The first given current is 1 ampere DC current is first given. Second one, if a current of 3 sine 314 t amperes is the second current. What is it here? First current is DC, second current is AC. You are missing small thing here, sir. If you are giving AC, IT means AC. AC current is given. MI instrument. MI instrument reads which value? RMS value. RMS means maximum by root 2. Yes. So what is it? 3 by root 2 square. Or the DC. DC means average value only 1 square. This is playing major role. This is playing major role. Why? Maximum already has given 3. Maximum is 3 because Im sine omega t model 3. So what is RMS value? Im by root 2 is the RMS value. That is 3 by root 2 whole square. So therefore, what we can say now? Theta 2 is equal to 9 by 2. 9 by 2. So simply you'll be getting 90 degrees. So answer here is 90. Yes, many people got it. Many people gave 90 only, but only 1 or 2 people given different answer. Clear? Yeah, many people gave the correct answer. Okay, now let us do one more question. Right. A moving iron voltmeter has an inductance of 0.6 Henry and a resistance of 2500 ohm for full scale deflection corresponding to 250 volt. Up to this only, what is the given data? Let us see. See, moving iron voltmeter. R is there, L is there, RM and LM, right? And sir, it is giving the full scale deflection for how much voltage? 250 volt. What does it mean? If 250 volt is given, this entire device is giving full scale deflection, IFSD, full scale deflection. Okay, sir. If 250 volt is given, he has only given full scale deflection. Okay, sir. What is the resistance value he mentioned? 2500 ohm. LM value 0.6 Henry. Now, sir, in this given data, can we calculate the IFSD value? Because he has given it full scale deflection corresponding to 250 volt. Means if you are giving 250 volt to this device, it will be giving the full scale deflection. Can't we calculate full scale deflection? Yes. What is that? Sir, IFSD is equal to V by Z. What is Z? Root of Rm square R square plus XL square XLM square. What is XL? 2 pi FL. F is given 50, right? 2 pi FL, right? Substitute and tell me this value. So many amperes. Rm is there, LM is there, XL means 2 pi FL. XL means 2 pi FL. Substitute and tell me. Everyone should respond. Right, come on. Why different answers? 0.0997 amperes. 0.0997 amperes is the answer. Okay, after that, what he has done, it went out 50 over. What series resistance is required? What series resistance is required to increase the range to 500 volt? He is asking only series resistance, not the impedance. Be clear. What is that? Sir, MI instrument, REM, LM, and only RSC he is asking. He is not worrying about the C. He clearly mentioned that what is the value of RSE, right? What is REM? 2500 ohm. This is RM. This is LM, zero point 0.6 Henry. But how much voltage he wanted to give? 500 volt. Sir, all I told you, before and after connection of this, its scale value, its construction operation value should be same or should be different here? Should be same. That's why my question is, sir, before connecting the RESC, whatever the full scale reflection current is there, and after that, even if you are connecting 500 volts, can we take same IFSD or not? Yes. Why? Why? Be clear, guys. Don't think like this. Sir, RSC is connected over here. Therefore, current should be disturbed. Be clear. If the current is disturbed, what is it here? That will disturb the corresponding, what is that, circuit. That's why whatever the IFSD current was there, before connecting the RSC, before connecting the RSC, and same current will be the two. He is asking, what is it? How much RSC is required to increase the range up to 500? Means 500 is the maximum value he is asking. Yes, maximum. Therefore, full scale deflection will be same only. Why? Before and after. Here 250 full scale value, IFSD this one, 500 full scale value. Don't think that this current should be increased. If it is increased, it will damage the corresponding device. That's what the very important point. So therefore, after this point, very simple, sir, IFSD is equal to, again, V500 by R. What is it? REM is there, RESC is also there. REM plus RESC whole square. REM plus RESC whole square plus, what is that? XLM square whole root. Right? Now all values are there. IFSD is also there. 0.0997 amperes. Take it. Finally, find out RESC value. This is what the general standard procedure to find out this. Alan Matthew, why we are not using ZSC means ZSC in the question only answer is there. ZSC means you will be getting ZSC, but what he's asking only RSC, only RSC. In your question only answer is there. See the question clearly. What he's asking, right? Resistance, not impedance. Resistance only he's asking. Balakrishnan, is it 2507? No. I gave the formula. Kindly use those and tell me clearly. Very good. 2510.65 or 64 will be there. One method I'm doing, first try to understand. After going home, other method you find out. Other method you apply. If you're getting the same answer, your method is correct. If you're not getting the same answer, your method is wrong. That's it. Or approximately we can say 2511 ohms. 2511 0.11 ohms. Right. Right. Now people's many doubts because of lack of network theory basics. People are asking this, sir, this is instrument. What is it? RM and LM is there. RM and LM. Concentrate. If the network theory is over, then you can understand. This is 500. What people are saying, sir, across this 250, across this 250, can we take? Come on here, it is AC. AC means it is not the arithmetic sum. AC means which sum here? VR plus VL means voltage across R, voltage across R. These to be combined and VL should be separate. That to vector sum. What is the formula? VR square plus VL square root is equal to supply voltage. But what people are thinking, sir, here he has given this is 250 volt. Therefore, 500 divided by 2, 250 and 250. No, yeah. 250 and 250 if you take, what is it? RL combination. One thing, R other combination. No, yeah. Be perfect in the AC analysis from the network theory. This is wrong. We cannot do at all. Right. See, I told you one method I have done. One method I have done. So why can't that method after going home? Do you do that? If you get the correct answer, that is correct. Wrong answer, that is wrong. Clear? And people are asking again, sir, why IFSD same? Means you did not understand the yesterday's class and today's class, right? Before and after extension, what I told you, full scale deflection should be same. Nothing but scale value, full scale value will be same. I told you one point clearly. That only have taken IFSD should be same. Why? Before extension. After extension, the full scale value of the device should be same. Full scale value of the device should be same. Okay, right. Now concentrate. I'm giving one homework question. In this only, I'm giving homework. What is that? Yeah, very good. Balakshmi, yeah, that's what. Right, sir. In this question, he is not asking the capacitor. Why means I don't know why he is not asking. In this question, only RSC he has, only RSC formula you have taken. But many people's doubt is that generally that will be given as the practice question. No need to worry. Sir, homework. Sir, why not ZSC? Zm into V by Vm minus 1. You simplify this, get the ZSC. After that, C is equal to 0.41 Lm by RSC square. Get the C value. After getting this, sir, ZSC is the parallel combination of RSC and RSC parallel with C, right? ZSC, C, simplify and determine RSC. You will get the same answer. You should get the same answer. Then this is correct. Of course, this procedure is correct only. You take this. Take this as a homework, everyone. Take this as the homework, everyone. What is it? Many people, the moment I'm starting, tension, always. So why not that? Why? Come on, yeah, take this, yeah, take this. What I'm taking, first take that. After that, after going home, you need to practice. Not only I'm giving the hint also, how to proceed and all. Find out ZSC, find out C value, because LM is there, RSC is there. Based on this, both should be same. Decimal point maybe, because you are not taking all the decimal, no, maybe, but correct answer should be there. That's why first take the procedure and question and the concept, whatever is given by the faculty. After that, after going home, it's your duty. Why it is not there, why it is not that, etc. Simple logic. In the simple way, I want to add 2 plus 3. What I will add? I will add with fingers. 1, 2, 3, 1, 2, like that. Sir, why only fingers? Why not finger lines? That your wish. Sir, why not lines like this? 1, 2, 1, 2, 3. I will do. That is your wish. Yeah? First, try to understand the procedure given by the faculty. After that, after going home, it is your duty to follow those methods. Right? In the classroom itself, one question, 25 methods is not possible. Okay, one question, one method will be given. Other method you need to practice. That is what called as preparation. Very good. Shivnath Ganesh, sir, I got. Very good. Yes, got it. Right. Now let us take one more question. The current I of t passing through 10 ohm resistor as shown in figure A, as a waveform shown in figure B. This here, this is B. Then the resistance of the DC voltmeter is connected across 10 ohm resistor. Connected across 10 ohm resistor. What is it? DC voltmeter means automatically PMMC. PMMC reads which value? Average value. So you need to find out V average. So he is asking V average. Right. You have done seen many questions when the PMMC was taken. Now tell me. Right. Naga Vinita. He has got the same value. Very good. Very good. This is called as getting the subject. This is called as getting the subject. I told you to do this. Yes, they have done. That's it. That is what the thing. Whenever I'm saying to do that, do that at that time only. At that time only you have to do. Right. Many people give the correct answer. Very good. Sir, what is I average? Because it is current. I average equal to, what is it here? Again, one cycle. One cycle you have to take. One cycle time is 2t seconds. Area. What is the area? This entire area is 0 to t. T into 12. 12 into t plus. What is this area? T into 5. So 5 into t. Tt will be cancelled. 17 by 2. 8.5 ampere. Don't get stuck up here, sir. 8.5 is not there. He is asking the voltage when connected across resistor. Therefore, V average is equal to I average into 10 ohms. So automatically 85 ohms. Clear? Right. Next. The mutual inductance of a 25 ampere dynamometer type ammeter changes uniformly at 0.2 microhenry per radian. The spring constant is 10 power minus 6 Newton meter per radian. Determine the angle of deflection. Determine the angle of deflection. Try this. Right. Two different answers people are giving. 62.5 degrees, 62.5 radian, 5, 125. Five different answers. 125 degree, 125 radian. Concentrate, sir. Here, determine the angle of deflection. Theta is equal to I square by Kc dm by d theta. In the dynamometer type, sir, I square 25 square. Kc, what is it? 10 power minus 6. I'm writing the unit also. Newton meter per radian into dm by d theta 0.2 microhenry per radian. Clear? Right now, simplify this. Very, very simple. 250. Here, micro is cancelled. 0.2. 25 into, so 25 square, sorry, 25 square, 625. Clear? Now, at least tell me the answer. What is the value? How much are you getting? Yes, 125. Got it? Dynamometer means not wattmeter. Dynamometer, ammeter is there, voltmeter is there, wattmeter is there. That's why 25 ampere device means he is operating the dynamometer as an ammeter. It doesn't matter here. It doesn't matter. Now question is, sir, is it in radians or degrees? Is it in radians or degrees? Mobile, I'm coming to that only. Is it radians or degrees? Come on. Be clear. Unless and until it mentioned as the degrees, we should take it as radians only. But you may feel it, sir, 125 radian will be very, very large value. No, yes, actually, spring constant will not be like this. Spring constant will be 25, 35, like that will be given actually. So that's why it will be in radians only. If it is mentioned as degrees, if it is mentioned as degrees, automatically, it should be degrees. People are asking this, sir, radian, so what? Theta. Can you say no unit? No. By the structural concept, theta is always in radians only. But people are immediately answering this, sir, 125 radian is very large. So what? Corresponding to the given data, yes, it is correct only. No need to worry. Right? Next. One more question. Zero to 1 ampere moving iron ammeter has an internal resistance of 50 milliohm and inductance of 0.1 millihenry. Shunt coil is connected to extend its range to 0 to 10, means 0 to 1 to 0 to 10 for all operating frequencies. The time constant in milliseconds and the resistance in milliohm of the shunt coil respectively are. Try this. Try this, everyone. Come on. Right. Very, very simple. Yeah. Sir, constant. What is the time constant in millisecond? He's asking. What is that? Tau sh is equal to tau m. Direct answer. What is tau m? Rm by, so Lm by Rm. What is Lm? 0.1 milli by Rm 50 milli. So therefore, what is that? 0.1 by 50. So 1 by 500. So therefore, what is the value? Millisecond, no? 0.002 seconds. So therefore, what is it? 2 milliseconds. This is what one answer. But 2 milli, 2 milli, 2 milli, three options are there. Definitely have to go for resistance in milli ohm of the shunt coil. RSH value, you need to calculate. How? Get it? Get this value? Right. How did you get 5.55? Yes, answer is this, correct. How did you get? Time constant is there. Yes, people give the correct answer. Yes, IM values are given. No. Yes, by utilizing those, find out that value. Yes, very good, very good. Many people give the correct answer. Yeah, basic formula of concept range extension. Very good. Right? What is it? Here. What is it? R SE is equal to Rem into M minus 1 model. This is series notation. RSH is equal to Rem by M minus 1 model. Right? With this ammeter, no here. Yes, RSH we require. RSH is equal to Rem. How much Rem? 50 milli by I 10. 10 by 1. So simply 10 by 1 minus simply 10 50 by 9, 5.55 milli ohm. Right? If it is a series, use this. Otherwise, leave it. Is a shunt? No. Yes, use this one. That's it. Right? So this is the total discussion regarding all the three instruments, that is PMMC, MI, and EMMC. Now, very, very small device, very, very small topic, that is electrostatic instruments. So what is electrostatic? Electrostatic means which charge will be there? Static charge will be there. What is it here? Static charge will be there. Means so far we have taken which one? Concentrate here. We have taken current, magnetic field, Thereby we have taken L concept or M concept, etc. We have taken PMMC, MI and all. But now we are taking a special topic, that is electrostatic. Static charge means which one here? Electric field means voltage is the concept. So far we have taken which is the concept here? Current is flowing to the coil, magnetization, thereby corresponding topics we have taken. But in this, which one guys? Simply voltage concept. Exactly similar to MI, but there magnetic field, here electric field. There magnetic field, here electrical field. I'm repeating. Their current concept, here voltage concept. Okay, right. What is that? Let us see now. Sir, electrostatic instrument. Concentrate here. Now I'm taking electrostatic instrument. Right, concentrate. Very, very, very important. Basic point is also there. Sir, electrostatic, static charge. So static charge means which field? Electric field, not magnetic field. Yes or no? And then voltage. If you apply the voltage based on the two plates, so charge will be that is called a static charge. Which principle? Capacitance principle. So far we have taken inductive principle. Now we have to take capacitance principle. That's it. And see, this is directly called as electrostatic voltmeter only. Means I'm saying that only voltage measurement. Only voltage measurement. Right? Why not current measurement? Only voltage measurement. Why not current measurement? That is what the point. Actually, in the textbooks, electrostatic instrument are also given as electrostatic voltmeter. Sir, electrostatic ammeter is not there. Why? Means be clear, be clear. Sir, this is directly proportional to voltage. Okay. Suppose finally, if we get theta proportional to V square. Okay, voltmeter. Why? It is a voltage concept, electric field concept, and static charge concept. Okay. So after this, can we write like this? Theta proportional to V square proportional to I square. Therefore, ammeter. Can we write or not? Never, never. Because current proportional to voltage is correct, but voltage proportional to current is wrong. That's why now I'm asking the question, among these two, right, which is correct? I proportional to V is correct, or V proportional to I? Means supply current, supply voltage, supply voltage, supply current. Which is correct? Means be clear here. Ohm's law states that current through the coil, current through the conductor, current through the element proportional to voltage, but supply voltage never proportional to supply current. Always supply current only proportional to supply voltage. Therefore, this is wrong. You guys see? This is wrong, not correct. I proportional to V is only the two. What is our I? Supply current. What is our V? Supply voltage. Based on the supply voltage, supply current. Based on the supply current, voltage drop. But I'm not asking voltage drop. Our topic is how much supply voltage, etc. That's why always, which is correct here? I proportional to V only. That's why V supply voltage proportional to supply current, completely wrong. That is reason. Basic electrical principle here. This is not of gate level, simply basic electrical principle only. That's why if the instrument is with respect to voltage concept, the instrument is with respect to voltage concept, automatically we should say current measurement is not possible. That's why these devices are directly called as electrostatic voltmeters, because V proportional to I or V square proportional to I square. We cannot say why. Supply voltage cannot be dependent on supply current. But you may be saying that, sir, I have studied that V proportional to I. Yes, but that is voltage drop. Voltage drop. But our topic is supply given. So therefore, supply voltage never. And what about this fluid friction damping? I'll tell you later. Okay, right, sir. Here, this is the simple idea about the construction and all. Two plates will be there. Everyone, concentrate. Two plates will be there. supply is given here. Due to that supply, positive and negative charge will be taking place. Therefore, suppose this is the fixed plate I'm making, this is a movable plate. Automatically, movable plate will be getting attracted towards the fixed plate. Therefore, what is it here? It is getting attracted means deflecting torque is there. And sir, what about the spring is there? It is disturbed. It is disturbed. So controlling force. Therefore, one way deflecting, one way controlling. Everything is similar. But sir, which type of damping? Fluid friction. Why? I'll tell you later. Only what is it? Deflecting torque and controlling torque. Both are in the opposite direction. Yes or no? But don't worry. In the corresponding system will be designed like this only. STD will be like this. That will be taken care by the manufacturer. No need to worry. Sir, this is which type of motion? Linear motion of the plate. Okay. Second thing is also there. That is angular motion of the plate. Sir, one is a fixed plate. One is a fixed plate, positive charge. Movable plate, negative charge. Sir, both fixed and movable plates are getting attracted. Why? One is getting positive, one is getting negative. Sir, why? Means I am giving the supply like this. I am giving the supply like this. Positive supply, negative supply. So this is positive charge, this is negative charge, for example. Automatically, opposite charges attract with each other. But in this which type of movement? Angular movement. As it is angular movement, what is it here? TD in this direction. Based on this movement, spring gets disturbed. TC will be there. Finally, pointer. Intentionally, I'm not showing the pointer structure because three devices we have taken. No, yes, we should visualize that. Simply pointer will be there. TD and then TC will be there, obviously. But again, sir, which type of, come on here, which type of damping is used? Means fluid friction damping. Why? I'll tell you later. Clear? Right. This is a simple introduction regarding constructional part. This is a complete introduction. How the figure will be there and how the corresponding different motions are there. Okay. This is angular motion. Means in this, two things are possible. This is linear motion. Very small topic. The two, it is just like a revision, but with which concept? Voltage concept, static charge concept. That's it. Okay, right, sir. Same mathematical discussion. What is that? Concentrate. Just it is a homework thing, but I'm showing you everything here, sir. I is equal to d by dt of CV. Okay, right. I is equal to C dV by dt, V dC by dt. My question is, sir, as the movable plate is moving like this, capacitance will be constant or variable? Variable. As the plate is moving like this, capacitance will be constant or variable? Variable, because C is equal to epsilon A by D. D is varied. Automatically, C will be varied. Yes, same discussion. Actually, generally, I will give homework every time, but I'm showing dt bringing here I into dt, C dV plus V dC. V I'm multiplying both sides, V into I into dt, CV dV plus V square dC. If you observe this, same type of formula we have got in the yesterday's topic in MI instrument. What is that, sir? Concentrate here, sir. Here, LI DI notation here, CV dV. Otherwise, if I want to write total thing, V into I into dt is equal to Li di plus I square dl. So V into I into dt, energy supplied. Okay, after that, L there, inductive. C here, capacitive. Just logic I'm giving. I is the concept because magnetic field current concept. V is the concept field. And di, they're changing current here, changing voltage. I square current concept, V square voltage concept, inductive concept, capacitor. That's why if you are able to recollect the corresponding MI structure, same thing will be there here also. But just I'm explaining it. Otherwise, similarly, you can take it and I can give the formula, but I'm giving the total discussion. After that, same thing, sir. Here, similarly from MI instrument, Similarly, from MI instrument, what is it? Energy stored in dt seconds. Sir, energy stored in dt seconds, what we have got? Li di cv dv plus half I square dl v square dc. Only to revise the MI, I'm giving this entire explanation. That's it. Okay, so therefore both are similar, not same here, both are similar. That was inductive, magnetic field, current approach. Here this is capacitive, static charge and voltage approach. Therefore same equation. Energy output is anyway TD into d theta. Same logic, same logic. That's why I'm keeping the dots like this. Kindly, whatever I have taken in the MI, you take it, otherwise no problem. After that, energy conservation principle. What is that? Equation 1 equal to equation 2 plus equation, same thing. CVdV plus V square DC is equal to CVdV plus half V square DC plus TD into d theta. This is equation 2. This is equation 2. Same thing here. Everything is same. I'm repeatedly saying their inductive, here capacitive, their current, here voltage, their magnetic field, here electric field. Can anyone answer? Those who have completed with network theory, those who have completed with network theory, what is it here? This is based on which concept? Means concept is okay, but this is based on which concept we can analyze also. Network theory, those who completed, one word is there, the network theory, one topic is there. Duality. What is it here? Duality concept. Okay? Duality concept. In the duality, L is replaced with C. C is replaced with L. So therefore, magnetic field is replaced with electric field. Electric field is replaced with magnetic field. Like that, based on that also, mathematically can write. But concept I'm giving without this entire thing. Inductive, current, by duality principle, inductive becomes capacitive, current becomes voltage over. Same principle. Sir, half V square dc by dt, angular motion based only. Suppose if you want to write linear motion based, what we can write? Simply fd half V square dc by dx. Here, sir, dc by d theta. Here, dc by dx. Why? This is linear motion. This is angular motion. Very, very simple. Okay, means I'm writing here instead of td into d theta, fd into dx, by thinking that linear structure. So both will be same only. Both will be similar only. But one is linear, one is angular. Both I'm writing. After that, angular formula we prefer generally Tc equal to Kc theta. Finally, at final steady state position or final position, Tc equal to Td, Kc theta. Same thing here. There I square by Kc. Here V square by Kc. There dl by d theta, here dc by theta. Don't think that, sir, you have gone very fast. Actually, this is the homework. Generally, in every batch, this will be given as homework generally. Yes or no? But just for clarity purpose of revision point of view, I have taken this entire thing in the class itself. Therefore, theta proportional to v square. Why? Same discussion. Sir, dc by d theta constant. If assumption, no problem. Kc is constant, theta proportional to v square. That's why I am giving one simple shortcut now. Sir. dl by d theta, dm by d theta, and dc by d theta must be taken as constant for analysis purposes. Take it for granted. Approximately small change may be there, but it is negligible. So therefore, we can take yes, universally constant. Clear? And final conclusion. What is that? Here, theta proportional to v square, non-linear, non-uniform square law scale. Non-linear, non-uniform square law scale. Okay, but very, 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 very important electrical basic point I'm giving. Concentrate. Sir, electrostatic instruments are generally designed to measure larger voltage. This is a practical application. That is the reason why in your laboratory, electrostatic instruments are not used. Why? In the laboratory, how much is the voltage? 230 volts single phase. Suppose if you go for three phase, 400, 440 volt will be there. That is not high voltage. That's why with MI instrument, we can measure. But these electrostatic instruments are this is a practical design, generally, generally designed for higher voltages. Very, very important, sir. Higher voltage, very, very important concept. Concentrate. Electrostatic instruments are generally designed to measure high voltages. First point, sir. High voltages is available in the college laboratory or in the industrial application, means industrial. That's why here high voltage in terms of kilovolts we say. In terms of kilovolts we say 11 kV, 33 kV, like that voltage you can measure with this electrostatic instrument. These are directly designed for higher voltages, kilos of volts. Okay, sir, high voltage where will we finding means industrial application. Therefore, electrostatic instruments are finding the application in industries. Now, very, very, very important, just a practical point, sir. In the industrial applications, most of the devices are carryable devices or portable devices are wall mounted or panel board mounted devices. Come on, guys. In the industrial applications, here in the industrial applications, most of the devices are, what is it here? Panel board mounted, or we can say wall mounted devices only. Wall mounted devices only. Okay. Therefore, as these are panel board mounted devices or wall mounted or what is it here? Simply vertically mounted devices, we can go for which type of damping here? Fluid friction damping. I told you fluid friction dampings are used for vertically mounted. If these are vertical mounted, we can use. These are vertical mounted, we can use these devices in the which one? Fluid friction concept. One thing. That too, as these are high capacity based, in the fluid friction which is there here, oil will be there, fluid will be there. Therefore, this will be acting as cooling medium also, insulating medium also from any sparking, etc. Because larger voltages will be there. Therefore, safety is a matter. That's why, yes, fluid friction damping is giving cooling arrangement also. What is it here? And for the insulation purpose also. That's why in the electrostatic instruments, we use fluid friction damping. But sir, if you use air friction damping, what happens? Nothing will happen. You can use air friction damping also. But compared to air friction damping, fluid friction damping is a little bit more strong, I told you, more effective. That's why it is suitable. But problem is there, sir. Fluid friction means cleaning problem, oil problem, etc. will be there. That's why according to your requirement, sir, I'm not bothered. I'm least bothered about cleaning and all. You can go for fluid friction. Sir, I don't want to go for cleaning and what is it? The unclean system, etc. You can go for air friction. But generally, first preference is fluid friction. I'm coming again the total concept and explain. Listen carefully. In this, fluid friction is used. Why? Why? Means the devices are wall mounted. Sir, why the devices are wall mounted? Because these are industrial application. Okay. So why these are industrial application? These are designed for high voltage capacities. That's what the actual theory. But don't say air friction cannot be used. Air friction can be used. Fluid friction can be used, but fluid friction is more preferred. More preferred. That's why electrostatic instruments are generally not portable, generally wall mounted only, we can say. Suppose people are asking, sir, in our laboratory, high voltage, because electrical people, high voltage lab is there, sir. In that, electrostatic instruments can be used or not? You can use. But in the laboratory, generally, portable devices will be there. There, fluid friction not used. Which one? Air friction damping can be used. But generally, electrostatic instruments based on the industries only we consider. That's why if question is given like fluid friction only, you can, in that option, air friction they will not give, no need to worry. If air friction is given, controversy will be there. So both are used. They have to give both A and B like that. That's why based on the options, you need to proceed. This is what the complete discussion regarding what is it? Instruments chapter. PMMC, MI, EMMC and electrostatic instrument chapter. Clear? Right. Now, let me take one electrostatic instrument question here. Right. See, I will explain the things by writing only. Don't worry. Wherever only repeated things are to be written, I am taking the written part like this. I will be explaining both the ways. I'll explain the both the ways. As it is online, I'm utilizing this facility to spend more time in the explanation point of view. That is what the point. Harshvardhan, don't worry. Right? Not to everyone, only wherever the repeated, because electrostatic is completely repeated topic only, complete derivation. Yes, I'm taking that. That's it. Right? Okay, now one question I'm taking here. An electrostatic altimeter has a movable circular plate, movable circular plate of 8 centimeter diameter, 8 centimeter diameter. Okay. During a measurement, during a measurement, the distance between the plates, the distance between the plates is found to be 4 mm, 4 mm, right? Find the applied voltage when the produced force or developed force is 0.002 Newton. So force is given means you have to take linear displacement notation, force notation. But plate structure is circular plate. How to proceed? Try this. Take 2 minutes of time and try this. Come on. Very good, very good. Gurudatta Behra, right, correct. Vinita, no. All I told you high voltage, no, here you got 0.0142 volt. No, actually, with this numerical question, I would like to show, yes, it is applicable generally for high voltage. Right, be clear. Right, solution, sir. C, what is the formula? FD is equal to half V square into dc by dx. So F is given. V you require. For that purpose, what you require? dc by dx you require. That's the first observation. Second one. So C is equal to epsilon A by D. Epsilon A by D. So distance I'm writing as epsilon A by X for clarity purpose, because area, diameter problem is a confusion. So simply X I'm writing. Okay, sir. Therefore, dc by dx is equal to, what is that? Epsilon into A minus 1 by x square. Minus 1 by x square. Clear? Right, sir. What is that? The minus epsilon A by x square. But minus sign indicates only direction. What is it? If the distance between the plates is reduced, what is that? Capacitance will be increased. Distance between the plates is reduced, capacitance will be increased. Inversely relation. For that purpose only minus sign is there. But in the formula, no need to worry. Therefore, FD is equal to half V square epsilon A by X square. Everything is there. F 0.02 half V square we don't know. Epsilon 8.854 into 10 power minus 12. Epsilon R is one, nothing is given. Area of the circular plate pi by 4. D 8 into 10 power minus 2 square, because meters, and 4 mm 4 into 10 power minus 3 square at least. Now simplify this and tell me the value. So many ohms. Come on. At least no. Yes, Pragati correct. Other people wrong. And Sambandhamurthy correct. 12 koi, approximately 12 kilo volt. Check it here. That's why generally that electrostatic instruments are designed for higher values only. Right. Tulasi, what do we reduced area? Area will not reduce. Area of the plates will not be reduced. Only distance. Area means not area between two plates here. Area of the plates. Area of the plates. That's why plates are same. Only distance is changing. Distance is changing. One student is asking this, sir, this is a torque formula. No, not force. Already gave you. For linear motion, linear force will be there, linear displacement will be there. This is angular only. I told you here, you take FD and dx here, linear notation. What you get? Yes, FD formula already I have given clearly. dc by dx. That's why you can use the same formula. This is linear force moment, because he has given that linear displacement as distance between the plates is 4 mm, etc. They have given. Yes, 1.19 kV or 11.9 kV. Vishnu. Right. I'm repeatedly saying it is not dc by d theta. It is dc by dx, because the distance between the plates is given in mm, not theta. If theta is given, take this one. Take theta is given, take this one. Angular displacement they will give. But these type of questions will be with respect to linear displacement only, right? Approximately 12. Yes, Varsha, correct. 11.9 and yeah, 12 kV, no problem. This is the total discussion related to all types of instruments, PMMC, MI, EMMC, and corresponding electrostatic instruments with all concepts, corresponding comparisons, advantages, disadvantages, finally, which is preferred, which is not preferred, and numerical questions also we see. Right now, next chapter, just introduction. Next chapter, every day I'm maintaining like this only because I can repeat this same thing in the next class. That's what the plan actually. The next chapter, very lengthy chapter. The two major chapter, the two major weightage also will be there. Measurement of power. Measurement of power. Right? Sir, we have taken, no? Yes, we have taken so far. Which device is used for measurement of power and all? Now we are going to take different circuits, power we are going to take. Different circuit, power we are going to take. And previously, electrostatic instrument only introduction topic is only there. Extension and all is not there. I'm repeatedly saying this point, everyone. See, according to the present day syllabus only, the preparation should be there. Long back, 1995, at the time, galvanometer constructions were there. And in the 2019-95, etc., electrostatic voltmeter extension also was there. EMMC extension also was there. Slowly they're reducing the syllabus because what is that? Mathematics is added, aptitude is added. In the English and general studies, everything is general aptitude, everything. That's why they are reducing the weightage of this one. Clear? So no need to worry. So there is an error problem related to op-amp came. Yeah, actually very good. Ankur, I will like to say everyone also. In 2020, operational amplifier based measurement question is given. That is the combination of analog electronics as well as correspondingly measurement topic. But that question is ambiguity is there. We gave one solution, not only we gave, all the people gave one answer, one solution, but IIT people gave other answer. But how that answer is coming, so we are not getting. That's why the ambiguity is there. So that's why leave it, no problem. But they have not accepted. Everyone, see, one point I would like to say, after the GATE exam, there will be procedure called as challenging. Challenging means from student, what is the roll number and all hall ticket number, we will be not only be every people, every academy will be challenging that. If they're accepting our procedure is correct, they will say yes. If they're not accepting, they don't say anything. Simply they will take their answers. But strictly speaking, I will solve that question paper later. Accordingly, whatever the procedure we gave and everyone gave correct only, but they are not accepted. That's why ambiguity is there. Yes, leave it. That question will be solved later at the end of the subject. At the end of the subject, from chapter 1 to chapter last, again, previous questions will be solved, means again revision will be there. In my explanation, topic to topic question. At the end of the chapter, all the question means one revision. At the end of the syllabus also, subject also, all the questions from chapter 1 to chapter last, 1 to 1 to 1 to question will be solved. No need to worry. There is ambiguity is there, we cannot do anything. Right? Right. Sir, how to gain confidence that we can qualify the gate? Only one thing, I can. Plus, you need to have the daily preparation. Even you are missing one day, missing half an hour, think that your rank will be different. Means 1 rank to 10 rank you will fall. 10 rank to 20 rank, 20 rank to 100, like that will definitely every day, every minute from day joining, the starting day of joining to GATE exam, without missing any single minute. You need to attend the classes, you need to have the practice. Then only you will get the confidence. But if you do like that, 100% you will get the things. Definitely, no need to worry. Right? Electrostatic instrument extension, not there, already told you, right? No need to worry. Clear? Right. One question I'm giving here. See, for clarity purpose, don't think like, sir, in the ambiguities like that, people are getting negative thought. That's why Simply, one question is there in the network theory, right? Here, everything is equal resistor R, etc. Right? Between A and B, between A and B, how much is the resistance? Between A and B, how much is the resistance? Each branch is having R, etc. Current is I divided, etc. When I teach a network theory, I will solve this as RAB is equal to R by 2 something. Right? Few people are teaching like this one, but few people are bringing some other answer. It is also ambiguity, but both are correct only. But which is finally decided? Not yet concluded. That's why few things are there, ambiguity questions are there. So don't worry. Yes, equipotential concept are way to live there. But few people are solving this by superposition theorem. But in order to apply the superposition theorem, some other conditions are required that is not acceptable here. That is what the ambiguity is there. Those type of questions, leave it, no problem. Controversial topic, not questions. Controversial concept itself is controversial, so no need to. Right now, sir, measurement of power. What is the introduction taking, sir? In this DC power, and other one is AC power. We are going to measure each and every power. In the AC power, again, single phase AC power, three phase AC power. Okay, right, sir. DC power, what is the formula? P average is equal to V average into I average, general formula. Sir, single phase AC power, power single phase is equal to V phase, I phase, cos phi. Power three phase is equal to, what is that? Root 3 VL IL cos phi. Don't worry, we are going to prove it. But introduction, electrical people should know about the three phase power formula compulsory. Okay, sir. Sir, which type of device we use? DC power EMMC. Single phase is for EMMC. Okay. But other than that, EMMC already there. But other than that, I'm using PMMC, voltmeter and ammeter concept. Valid or not? We will be seeing that later. Okay. In this single phase energy, single phase power measurement, what is it here? EMMC we are going to use. Only which is a method I'm going to explain clearly. In this again, two connections are there. MC short connection, LC short connection. And in the three phase also, EMMC only we use. But sir, so far we have taken EMMC for DC power, EMMC for single phase only. How the three phase method is there, I will explain. Right? Very lengthy topic. The two major important topic in each and every subject. Here, three methods are there. One wattmeter method. One wattmeter method. Second one is 3 wattmeter method. Third one is 2 wattmeter method. 1 wattmeter, 3 wattmeter, and 2 wattmeter method. So this is a simple introduction in the power measurement. What you have to take here? Different power measurement. What is it? DC power measurement. One topic. AC power measurement in the MC short and LC short concept, and three phase AC power 1 wattmeter method. One topic, 3 wattmeter. Very lengthy topic, and various number of questions are possible in this topic. We are going to solve everything. Tomorrow we'll continue this measurement of power. Okay, right. Now I'm stopping the session. Let us have the doubts session. Let us have the doubts session. Yogesh Gaikwad, in last question, please explain why area is divided by 4. Where have you divided the area by 4? Right? Circular plate area is pi by 4 d square. In the question, diameter is given, not the area. Only diameter is given. Right. Vinitha, preparation strategy. Yes, yes, I will explain. 1 second. 57 ZSH. Sir, these is for ZSH in 57F. 57 if nothing is there. Sunil Wagner, so much difficulties in today's problem. Which problem? Which problem? So many difficulties. Where you are feeling like that? So many difficulties. Come on. Sunil, which problem? Right. See, concentrate. In the questions, I clearly told that in the measurement of that, I gave you clearly. 1 second. I'll be going to that question. This way. Sir, I'm having doubt where should I use ZSC and where should I use RSC. If he is asking series resistance, use RSC. Use RSC. If he is asking series impedance, use ZSC. Okay. And normal method I have taken simple V equal to I into R model. Otherwise, sir, normal method, whatever the method we have taken, ZSC is equal to Zm into V by Vm minus 1. You will be getting ZSC. By using the capacitance formula, you will be getting capacitance. By using these two, you can get RSC. That only I gave you as the homework. You will get 2511 ohm. Okay. One more doubt chance is there here. Sir, here you have used this formula. Why? All I told you in the yesterday's class clearly. You might have not heard because you are keep on typing. Alan Matthew, always you keep on busy in typing. No, you'll be missing definitely. Definitely you'll be missing the topic. Always you're busy in typing the questions only, not listening the class. Okay. ZSH is equal to Zm by M minus 1. I told this, sir. RSH plus, what is it? XJ XLSH is equal to Rm plus J XLM by M minus 1. In the question, if L is not given, this will be removed. RSH equal to Rm by M minus 1. That only will take. Because you need to calculate only RSH. If you would have listened this point when I was explaining MI, there will not be any doubt on this. Right. And people are asking, okay, actually I wanted to give that, I forgot, no problem. Here, yes, I'm giving those. M, main, L, load, C, common, V, voltage. Load means current. So therefore, M and L, this is M. L means load, load means current coil representation. After that, one terminal is common because to connect both, and other terminal is V, voltage. Okay. Yes. Thanks. Could you explain dC by dx formula? dC by dx question. See, what is it? What is the difference? What is the problem here? dC by dx. dC by dx. So differentiate this one. Differentiate. Epsilon A is constant. You are differentiating with x. You are differentiating with x here. You are differentiating with x here. So therefore, what is the thing now? Differential of x is, what is that? 1 by x is simply minus 1 by x square. Epsilon A minus x square is there. In the place of dC by dx, substitute this one. I did that only. But why I have not taken minus means minus indicates a relation, but we need magnitude. That's it, nothing more than this. Epsilon naught 8.854 into 10 power minus 12 into epsilon r1 area. You're missing something. Circular plate area pi by 4 d square. Pi d square by 4. Yes, pi d square by 4. D 8 centimeter convert into meter. 4 convert into meter. That's a 12 kilo volt. Mridul Sharma, I hope it is clear now. Ashish, I gave you terminals names. See, electrostatic voltmeter plate will be attraction because opposite polarities, no, yeah, opposite polarities automatically attraction. Right. Jitendra Latwal, I am getting 1.199 kilovolt. I have tried several times. You need to try again. Or 1 second. What I gave you? Come on, guys. Come on. Sorry, it is 1.2 kilovolt, not 12 kilovolt. Sorry. 1.2 kilovolt only. Sorry, 1.2. I think by mistake I have written 12. I think it is 1.2 only. Check it. Yes, correct. Who is this? Jitendra Latwal, correct only. 1.9, 1.2 kilovolt only. Not 12. Actually, I thought to write that, but 1.12 I have written. See, Govind Vikas. See, everyone, those who are on the line, listen his message. Everyone, Govind Vikas message, kindly listen. Sir, please send that PDF as usually. Don't corrupt, sir. Do you think I'm corrupting that file? So this is the message from the students. You think what will be the mentality of faculty then by seeing these type of messages? You can understand. Preparation strategy and all I'll give you later. Don't need to worry. Right. Priyavatraj, kindly go to the video and see that because total question explanation is not possible. Wherever the doubt is there, ask that only. Okay, sir, got it. DC, not with respect to steady state. DC supply, yes. Jnana Teja, right? See, DC, how the flux is there, etc. Come on here. We are keep on giving the supply means that coil is keep on moving. No, with respect to that, change in the flux is occurred. Not only with AC, with the body movement also. That only. See, answer is 1.2 only. Come on here, 1.2 only. Right. Sai Charan Reddy, question is itself is wrong. Sir, can we consider only with RSC without LSC? LSC itself is not there. LSC itself is not there. Go back to the yesterday's topic and see that with R, L is there or C is there. Right. So in last question, is it possible with electromagnetic field also? Capacitance itself indicates static electric field only, not the magnetic field. Capacitance itself indicates electric field, not magnetic field. Kindly take care. All Varun? Yes. Yeah, 1.5. Yeah, sorry, sir. Sorry, 1.2 kilovolt only. 1.2 only. 1.2 kilovolt only. Right. Right. See, sir, 52 question. What is your doubt here? All values are given. Just substitute it. Right? People are getting doubt. Sir, radians, everything will be cancelled. Then what will be the unit of theta then? Theta inherently in terms of radians. Theta inherently in terms of radians. Therefore, with the help of this entire thing, radians will get. Don't get confused with that. Yeah, 1.9, 1.19 only. Yes. Alan Matthew. Again, you're typing very lengthy message. Is that listening the other people doubts? Okay, very good. By the explanation you explain now, we will get XSE. We will get XSE. Where have I explained XSE? XSH, I told you. XSH. In the shunt notation. In the shunt notation I gave you, not that series one. Okay. And we also have the formula to calculate C. That only I gave you to have the homework question here. In this, right? Okay. Okay. We are getting two values right. And sir, I'm typing because my mic is not working from day one. Okay, no problem. I'm not opposing your typing, but I'm opposing your typing when I'm explaining continuously. Okay, as you wish, as you wish. I can't do anything right. Next. Very good. I'm reading one student message. Today class is very nice as compared to past classes because, right, it will be more interesting. That's why I told you. PMMC, something I missed. MI, something I missed in the study because I cannot give all those conclusions without comparing. Now I have compared all the instruments. That's why I told you. Until I conclude, you need to wait. But you don't have the patience, right? Not everyone here. This is not the statement to everyone. Only out of 500 members, only 5 members, only 6 members, like that. That's what. And please neglect the constant disturbance. Very good. In class, as we are neglecting very small errors in our subject and concentrate on really interested student. Thank you, sir. Very nice, very nice, very nice. This is what the subject gaining. Very good. See, why I'm saying all these means you should not make the mistake. That's what I'm pointing out you intentionally. Otherwise, my throat pain will be there. Otherwise, I will not get anything. Thank you. Thank you. Paul Varun, yes, if you are doing like that, change. But what is the charge? Do you have any charge? No. Right. Electrostatic instruments are both electrostatic instruments are both supply DC as well as AC. So no need to mention. Right. Gauselya Roy. Thank you. Thank you so much. Right. Now I'm unmuting the people. People are not having the patience until I unmute. Yes, come on. Every people's doubt, you are understanding now. 8:45 to 9:30 means 45 minutes doubts clarification I'm spending. Only 15 minutes time up to 9 o'clock only, but still I'm waiting. Kindly have the patience. Everything will be covered. Right. Then we Karan. Yeah.
Hello, sir. Hello.
Yeah,
Can you hear me, sir?
Yeah, yeah.
Sir, my doubt, I could not explain typing, sir. So
You what?
I could not explain my doubt while typing, sir. So I wanted you to
Yeah. No,
unmute, sir.
see. You can ask while what is it? Mic switch on. I'll give the permission. You can ask. No problem. I'm not
Sir,
saying you can ask. No problem. Tell me.
sir, I was revising, sir. I had a doubt in deflection torque derivation, sir. In it, we have taken at a current in an instant to be I, and then we have got that theta is directly proportional to I square, sir. Square law we have got, sir.
Theta proportional to I square. Okay.
Sir, my doubt is in AC current measurement, sir. Sir, my doubt here is, sir, if I is theta is proportional to I square, sir, how will the instrument know that it is the RMS value, sir? Because
Okay,
if
very
it
good.
is at an instant.
Yeah, I got it. Sir, suppose one AC is there. What is that? 15 amp, some device is there. 15 ampere AC, we say. What is it, 15 ampere?
So 15 ampere, generally, if it's given, it will be RMS value, sir.
Yeah. How does it know?
Sir, because that we are taking initially, like we are like in problems, if like it's a given, like
Same thing here also, right?
and then.
Same thing here also, right? If you are giving some AC current, means based on the AC current only, the pointer gets the deflecting force. You're missing this. You are giving some current. Suppose some device is there. Here load is there. Load is taking 5 ampere AC means how much it is taking? 5 ampere. Which current? RMS. Means according to this magnitude only the corresponding deflection will be there. That is what MI is applicable for both DC and AC. Means whatever the current is flowing, according to that current only, magnetism, according to that magnetism only, what is it? Torque, according to the torque only, deflection. Therefore, theta proportional to I square means it is RMS only. Yes.
Sir, okay, thank you, sir. I had one more doubt, sir, here. Sir, how is the torque steady, sir, then? Like, is the, like, till it's, till damping torque comes into play, sir, how is that we get a steady torque, sir?
I'm not getting your question.
My question is, sir, till initially that our
your Telugu person?
Yes, sir.
Yeah,
I'm Telugu, sir.
Yeah, Telugu అడిగాను.
Sir, no, I'll ask in English, sir, no problem. My question is, sir.
Clarity గురించి. Okay, మీ ఇష్టం.
My question is, sir, in this beginning, the deflection torque is greater than the damping torque, sir. So then, if will in the beginning, don't we observe any jerks in the torque measurement, sir? Or will it come smoothly, sir?
Bearings are there, no jerk. Bearings are for smooth movement.
Okay. Thank you, sir.
That's what. I'm unmuting one by one person. Kindly wait. Those who raise the hand, I'm unmuting them. Kindly unmute.
Hello, sir.
Yeah, who is this?
I'm UST, sir.
Yeah. Tell me.
Sir, మనము పిఎంఎంసిలో అంటే స్ట్రాంగ్ అని అనుకున్నాం, అంటే ఇండిపెండెంట్ గా అన్నారు కదా సార్.
అవును.
అయితే ఇండిపెండెంట్ ఎలా అవుతుంది సార్? సేమ్ వర్కింగ్ ప్రాసెస్ ఎంఐకిను ఈఎంఎంసికి కూడా సేమ్ అదే కదా సార్?
కాదండి, నేను ఏమన్నాను? ఇండిపెండెంట్ అనేది పర్మనెంట్ మ్యాగ్నెటిజం అనేది పిఎంఎంసిలో మీరు 1 ఆంపియర్ ఇచ్చినా 10 ఆంపియర్ ఇచ్చినా ఈ మ్యాగ్నెటిజం అనేది ఇండిపెండెంట్ ఆఫ్ సప్లై. అదే ఎంఐ అండ్ ఈఎంఎంసి తీసుకుంటే రైట్, మనం 1 ఆంపియర్ ఇస్తే 1 ఆంపియర్ మ్యాగ్నెటిక్ ఫీల్డ్ వస్తుంది, దాని ద్వారా ఫోర్స్ వస్తుంది. అంటే దీంట్లో ఉన్న మ్యాగ్నెటిజం సప్లై బేస్, అందుకనే ఇది సప్లైతో వేరేతుంది. కాబట్టి పాజిటివ్ కరెంట్ ఉంటే పాజిటివ్ ఫీల్డ్, సో టార్క్ ఈస్ ఫార్వర్డ్. నెగిటివ్ కరెంట్ ఉంటే నెగిటివ్, సో ఫార్వర్డ్ టార్క్ ఈస్ ఫార్వర్డ్ ఉంది. బట్ ఇక్కడ ఏంటి, ఈ మ్యాగ్నెటిజం మాత్రమే. ఆపరేషన్ అనేది కరెంట్ బేస్డే, బట్ ఈ మ్యాగ్నెటిజం అనేది పర్మనెంట్ మ్యాగ్నెటిజం అనేది. సపోజ్ 10 వెబర్స్ ఆఫ్ ఫ్లక్స్ ఉంది అనుకోండి, ఈ 10 వెబర్స్ ఆఫ్ ఫ్లక్స్ అనేది మన సప్లైని బట్టి వేరే అవుతుందా? లేదు. దట్ ఈస్ కాల్డ్ పర్మనెంట్. అందుకని ఇండిపెండెంట్ స్ట్రాంగ్ అన్నారు. ఇప్పుడు అడిగిన డౌట్.
ఓకే సార్, మ్యాగ్నెటిజం వల్ల ఇండిపెండెంట్ అవుతుంది, కానీ బేస్డ్ ఆన్ దేని వల్ల కాదు అంటున్నారు.
ఓకే, గుడ్ క్వశ్చన్ సార్. టార్క్ ప్రొడ్యూస్ అనేది మ్యాగ్నెటిక్ ఫీల్డ్ ద్వారా వచ్చేదాన్నే నేను ఏమన్నాను? స్ట్రాంగ్ అని అన్నాను, ఇండిపెండెంట్ అన్నాను. నేను టార్క్ ఇండిపెండెంట్ లేదండి, మ్యాగ్నెటిక్ ఫీల్డ్ మాత్రం ఇండిపెండెంట్. ఆ మ్యాగ్నెటిక్ ఫీల్డ్ స్ట్రాంగ్ కాబట్టి ఏమవుతుంది, టార్క్ కూడా స్ట్రాంగ్ అని తీసుకొని పిఎంఎంసీలో ఎర్రర్ తక్కువ అని చెప్పాను. ఇక్కడ ఏంటి, మ్యాగ్నెటిక్ ఫీల్డ్ డిపెండెంట్ కాబట్టి దాని డిపెండెంట్ ద్వారా టార్క్ వస్తుంది, కాబట్టి టార్క్ అనేది వీక్ అని చెప్తాం. అది పాయింట్.
ఓకే సార్. సార్ ఎంఐలో ఫిక్స్డ్ అని తీసుకున్నాం కదా సార్?
ఏదమ్మా?
అంటే ఫిక్స్డ్ కాయిల్ అని ఈ రోజు క్లాస్ చెప్పింది నోట్స్.
ఎంఐ అంటేనే ఐరన్ పీస్ మూవింగ్, కాయిల్ ఫిక్స్డ్. మూవింగ్ ఐరన్ అంటేనే నేమ్ ఏంటి, ఐరన్ పీస్ మాత్రం మూవ్ అవ్వాలి, కాయిల్ మూవ్ అవ్వకూడదు. ఒకవేళ కాయిల్ కూడా మూవ్ అయితే మూవింగ్ కాయిల్ అయ్యేది.
కన్స్ట్రక్షన్ డయాగ్రామ్ ఒకసారి తీరా సార్ ఈ రోజుది?
ఈ రోజు ఎంఐ చెప్పలేదమ్మా, కన్స్ట్రక్షన్ నేనే చెప్పాను.
ఈఎంఎంసీది సార్. దాంట్లో ఫిక్స్డ్ కాయిల్ 2 కాయిల్స్ ఫిక్స్డ్ కాయిల్స్ తీసుకుంటున్నాం కదా సార్? అప్పుడు అట్రాక్టింగ్ ఎలా అవుతుంది సార్? అంటే
అట్రాక్షన్ ఎవరు చెప్పారు?
అంటే మూవింగ్ కాయిల్ ఫిక్స్డ్ కాయిల్ మనం పిఎంఎంసీలో తీసుకున్నప్పుడు మిడిల్‌లో ఫ్రిక్షన్ అంటే మ్యాగ్నెటిజం వల్ల ఫోర్స్ ఏర్పడి టార్క్ ఏర్పడుతది గదా సార్!
అవును.
అట్లా అంటే అప్పుడు అట్రాక్టింగ్ ఫోర్స్‌ల వల్లనే
ఆ!
గదా సార్
ఎట్లా
వచ్చేది.
చెప్తావు? అట్రాక్షన్ ఎట్లా చెప్తారమ్మా? ఇది రొటేట్ అవుతుంది కదమ్మా! మీరు మిస్ అవుతున్నారు. ఇక్కడ కాయిల్ ఉండి, ఐరన్ పీస్ ఉంటే, ఐరన్ పీస్ అట్రాక్ట్ అవుతుంది లేదా 2 ఐరన్ పీస్ రిపెల్ అవుతాయి. ఇది మాగ్నెటిక్ ఎనర్జీ స్టోరింగ్ ప్రిన్సిపల్. ఇక్కడ ఇదేంలా? వెనెవర్ ఎ కరెంట్ క్యారింగ్ కండక్టర్ ప్లేస్డ్ ఇన్ ద మాగ్నెటిక్ ఫీల్డ్ ఎక్స్‌పీరియన్సెస్ మెకానిక్ అంటే ఇది ఎలా తిరుగుతుందమ్మా? గుండ్రంగా తిరుగుతుంది. అట్రాక్షన్ ఎక్కడుంది మనకి?
అంటే మూవింగ్ కాయిల్, ఫిక్స్డ్ కాయిలింగ్ ఉన్నప్పుడు తిరిగినప్పుడే గదా సార్ అట్రాక్షన్ వల్ల
అట్రాక్షన్ అంటే మీనింగ్
ఫోర్స్.
ఏంటి చెప్పండి? అట్రాక్షన్ అంటే మీనింగ్ ఏంటి? మూవింగ్ కాయిల్ ఫిక్స్డ్ కాయిల్‌కి దగ్గరగా వెళ్ళాలి.
యెస్ సార్.
ఇది ఎక్కడ వెళ్తుంది మరి? అమ్మ మరి వీడియో కూడా చూపించాను కదా! పీఎంఎంసీలో ఏంటి? ఇది మ్యాగ్నెట్ ఉంది. ఇది మ్యాగ్నెట్ ఉంది. నార్త్, సౌత్ ఉంది. ఇక్కడ అల్యూమినియం సిలిండర్ పైన కాయిల్ ఇలా ప్లేస్ చేశాను. కాయిల్ ఏమైనా నార్త్ సైడ్ గాని, సౌత్ సైడ్ గాని వెళ్తుందా అమ్మ?
యెస్.
ఏమవుతుంది? అందుకే ఇదేంలా అండి? లారెన్స్ ఫోర్స్ ఈక్వేషన్ సింపుల్‌గా అమ్మా. మీకు మెషిన్స్‌లో ఉంది గదా! స్టేటార్ ఉంది ఇలా. రోటార్ ఉంది. సార్ ఫ్లక్స్ ద్వారా రొటేట్ అవుతుందంటే రోటార్ మెల్లిగా ఎళ్లి స్టేటర్‌ని టచ్ అవ్వాలి మరి. టచ్ అయితే అప్పుడు ఏమవుతుంది? ఎయిర్ గ్యాప్ ఉండదు. 2 ఫిక్స్డ్ అయిపోతాయి.
యెస్
అవునా?
సార్.
అందుకని
ఆ!
ఇదేమవుతుందంటే ఈ మాగ్నెటిక్ ఫీల్డ్ రొటేట్ అవుతా ఉంది. ఎలా? లారెన్స్ ఫోర్స్ ఈక్వేషన్. మీరేం చేస్తున్నారంటే మూవ్ అయింది అంటే అట్రాక్షన్ అంటున్నారు. మూవ్ అయింది అంటే అట్రాక్షన్ కాదండి. అట్రాక్షన్ ద్వారా మూవ్ అవుతుంది. లేదు అంటే లారెన్స్ ఫోర్స్ ఈక్వేషన్ ద్వారా రొటేట్ అవుతా కంటిన్యూయస్‌గా రొటేట్ అవుతా ఉంటుంది. 2 ప్రిన్సిపల్స్ ఉంటాయి దీంట్లో. మూవ్‌మెంట్ అంటేనే అట్రాక్షన్ కాదండి. ఏంటది? ఒక కాయిల్ ఉండి ఐరన్ పీస్ అంటే ఏంటి? మాగ్నెటిక్ మెటీరియల్. అది అక్కడ ప్లేస్ చేస్తే అట్రాక్ట్ అవుతది కాబట్టి అది దగ్గరగా మూవ్ అవుతుంది. అక్కడ అట్రాక్షన్. ఇక్కడ మళ్ళీ ఎలక్ట్రోస్టాటిక్ లో కూడా ఇది పాజిటివ్ చార్జ్, ఇది నెగెటివ్ చార్జ్. ఇది మెల్లిగా దీని దగ్గరకు వచ్చింది. ఇవి 2 మాత్రమే అట్రాక్షన్. ఏనా? ఈ మూవింగ్ ఐరన్ గాని లేదా ఎలక్ట్రోస్టాటిక్ గాని అట్రాక్షన్ ఉంటుంది దీంట్లో. బట్ పీఎంఎంసీలో ఏం చెప్పానండి? నేను లా చెప్పాను కదా! ఏ కరెంట్ క్యారింగ్ కండక్టర్ ప్లేస్డ్ ఇన్ ద మ్యాగ్నెటిక్ ఫీల్డ్ ఎక్స్‌పీరియన్సెస్ మెకానికల్ ఫోర్స్. ఇక్కడ నార్త్ మ్యాగ్నెట్, ఇక్కడ సౌత్ మ్యాగ్నెట్, ఇక్కడ కండక్టర్. ఇది రొటేట్ అవుతా ఉంటది. ఇది ఇటు మూవ్ కాదు, ఇటు మూవ్ కాదు. ఇది అట్రాక్షన్ రిపల్షన్ కాదు. లారెన్స్ ఫోర్స్ ప్రిన్సిపల్. ఓకేనా?
Hello, sir.
Yeah.
Sir, in material, it is given that frictional error is moderately more in
I will discuss that. బట్ ఆ మెటీరియల్ లో గుడ్ క్వశ్చన్. మెటీరియల్ లో ఫ్రిక్షనల్ ఎర్రర్ ఎంఐ లో తక్కువ ఉంది, పిఎంస్ లో ఎక్కువ ఉందని ఇచ్చారు కదా!
yes, sir. Weight ప్రకారం చూసుకుని.
ఎస్. అక్కడ ఏమి ఇచ్చారంటే క్వశ్చన్ లో నేను ఏమని చెప్పాను? దిస్ ఈజ్ ఎంఐ, అవన్నీ నేను స్పెషల్ క్వశ్చన్స్ తీసుకుంటాను. ఓకే, అడిగారు చెప్తాను. అదర్ పీపుల్ ఆల్సో లిజన్ దోస్ ఫర్ ఆన్ ద లైన్. ఎంఐ, వాట్ ఐ ఎక్స్ప్లెయిన్డ్? టార్క్ టు ద వెయిట్ రేషియో. Torque to the weight ratio. In my discussion, weight is same. Mi torque is low, PMMC torque is more. So therefore, I told you frictional error is more in Mi than PMMC. This is the universal explanation. But in the material, I gave one question in that. What is that? If you see that question, he clearly gave that. What is it? If torque to the weight ratio, he clearly mentioned that weight of the moving object in Mi is less than the weight of the moving object in PMMC. ఆ కండిషన్ లో మనం వెయిట్ ని కమెంట్ చేస్తున్నాం కాబట్టి యాజ్ వీఆర్ కమెంటింగ్ ద వెయిట్, ద టార్క్ మస్ట్ బి, టార్క్ ఈస్ నాట్ మెన్షన్. He may be or he may not be mentioning the question. If these two are taken as constant, according this is question, but this is universal concept. This is question, this is universal concept. Now tell me, numerator is constant, denominator is less, torque to the weight ratio is more, torque to the weight ratio. According to the given question, what is it? Frictional error in PMMC more than Mi. Clear, Andy?
Yes, sir.
Hello, sir.
Yeah.
Sir, in page number 52, sir.
Page number 52. Yes. Come on.
Sir, here you cancel the radians and radians, no, sir. Then
Yes.
what about the Henrys and Newton meters, sir?
What about the?
Above micro Henry, Henry is there, no, sir.
Come on here. Ampere square Henry per Newton meter. I'm combinedly writing as radian. I'm combinedly writing as radian.
Yes. Okay.
Okay. Got it, Sai Charan?
Yes, sir.
Yes. Ashish?
Good evening, sir.
Yeah, good evening. Tell me.
Sir, on 5F.
Huh?
5F, page number 5F.
Page number 5F. Starting one, right?
Yes, sir.
Okay. Yeah.
Sir, here gives here deflection torque is directly proportional to 5C, 5P, then multiplication. Then here a term is coming at last ICIP cos phi. Sir, where this is this cos phi is coming?
Come on, very good. That's what I told you. Very good. See, current coil is low resistive. Okay.
Yes, sir.
Potential coil is high resistive. Current flowing through the current coil, current flowing through the potential coil will be in phase or will be differed by some angle.
So I think here they will be differ.
Yes.
So they will be differ.
Will be different, right? One thing. Second thing, sir, we are going for current measurement or voltage measurement or power measurement. Power measurement means one is with respect to two. One is with respect to voltage concept. One is with respect to current concept. So that's why be clear. What is actual logic here is TD proportional to phi C phi P. TD proportional to IC IP. Isn't it? But IC and IP, if you're taking nothing because AC supply, AC, that too, this is not current. This is the potential coil current, means voltage concept. That's why IC, if I'm writing V phase by Z, for example, so these two are in phase? No. Why? Angle will be there. That is what we are taking like this. Because whenever you're combining current and voltage, to find out the power and all, voltage and current angle we have to take. That is caused by that. In front step only I have written starting. That's it.
Okay.
Because if you are not taking this, it implies like, what is it? Both are in phase. Magnitude will be different. Isn't it? Suppose IC and IP both are in phase. What is resultant? IC plus IP directly. Or normally. If IC and IP is there, can we write directly IC plus IP? No. Vector common. Magnitude will be different. That's why this angle plays a role.
Okay, sir.
Clear, Ashish?
Yes, sir. One more doubt, sir.
Yeah.
Sir, here you just name the connections, sir. ML main load and C and B. So what C stands
I'm
for?
not able to listen. Kindly, a little bit louder.
Sir, here there are two coils,
Yeah.
and you named them as a reference of connection.
Yeah.
Main load.
MLCV. Yeah.
Right, sir. Then C and V.
Yeah.
So what C is here, sir?
Common. That's what I told you. Common means, what is it? You are connecting current coil and potential coil together. So some common point should be there. So that's why you need to go for common point compulsory. That's why current coil and potential coil. See, C means common. Common means either you connect like this, one second. You connect like this, or you connect like this. Means current coil and potential coil should be combined. In what way? Means some common point should. That's why C is called as common between current and potential coil in the entire circuit meaning.
Okay, sir. I think I somehow skipped that part. Sorry, sir.
That's what. It might be missed.
Thank you, sir.
Right.
Hello, sir.
Yeah. Mic is working, right?
Am I audible? Am I audible, sir? Hello.
Yeah. Tell me. You're audible. Kindly tell me. Alan Matthew. Yes, tell me. Tell me kindly. Those who raise the hand, kindly unmute from your side.
Hello, sir. Hello, sir.
Yeah, tell me.
Am I audible?
Yeah.
Yes, sir. Good evening, sir.
Yeah, good
Sir,
evening, good evening. Yeah.
sir, you read my question, but my doubt is not still cleared, sir.
Tell me the doubt again.
Yes, sir. Sir, in that total ZSE is equal to, so in that formula ZSE is equal to Zm upon M minus 1.
Yes. Yeah, you proceed. You proceed.
Yes, sir. So in that we will get RSC plus JXC, no, sir?
Where?
So in that formula of ZS, yes, sir. So in that
Yes.
ZSC will be RSC plus J times XSC,
No,
no, sir?
no. See,
Sorry,
I
sir.
told you ZSH is equal to Zm by M minus 1. ZSH is R plus JXLSH, Rm plus JXL, M minus 1. Here it is not there. That we have taken, I told you. You are missing small thing. Here, not, yes, not R and C series here. R and C parallel. RSC by 1 plus J omega RSC into C, that is equal to Zm by M minus 1. This is what the formula. Not
So,
R minus X, not R minus J, because RC parallel here. RC parallel means R by 1 plus J omega RC. Now we
okay,
can
sir.
answer.
Sir, but in this equation, RSC is unknown and C is unknown, no, sir?
RSC?
RSC will be unknown and C will be unknown, no, sir?
He has not commented C. Only RSC is unknown. Yeah, tell me. Only he is asking this only, right?
Yes, sir, but we can consider a case like, no, sir?
We should not consider, because he is not at all worrying about C. He is correcting only RSC.
Sir, so my actual doubt is, so here two variables, and in the formula of C, there is also a term of RSC.
Huh? Come again?
Sir, in this equation, there is RSC and C.
Okay. You are not listening, right? Okay, let me take, and I'll come in your way. Yeah, tell me.
And sir, in the formula of C, to minimize the frequency error, we are getting that 0.41 L by RSC square.
Yeah.
So in that also RSC is there.
Yes.
Like we are getting two equation, not linear one, and RSC is also there, C is also there. Here also RSC and C is there. So how will find the both value?
That's what I told you. People are continuously asking that, because sir, why can't we go by ZSC procedure? Means that is what the procedure, 0.41 Lm by RSC square. We got it? No. Yes. Go back to the earlier value 2511, substitute here and see, you verify. In that way, you'll get it. That's what I told you.
I'm not getting stuck to that question. I'm telling, for calculation of C, we need RSC, right?
Yes.
So from where we'll get that RSC?
Earlier I have solved, no? You substitute that.
So you are sticking to the same question, right?
You are? What is it? Repeat.
So you are pointing to that question, no, which you solved in class.
That's what. That's because that is the actual procedure. Because if you follow directly, RSC and C are unknown, directly we cannot proceed. That is the reason why I told you to follow my procedure. But for homework practice purpose, see what I told you, ZSC, Zm by M minus 1, you'll get it. After that, substitute my RSC value. Okay, get the C value. Then ZSC is equal to RSC by 1 plus J omega RSC C. Kindly equate these two, both will be same. This value and a combination of these two, you will be getting same that I told you.
Okay, sir. So, and one more doubt in that MI instrument of repulsion type I had messaged you earlier.
Yeah, tell me, repeat that.
Yes, sir. So in that one is fixed vane and other is moving vane, right?
Yeah.
And
yes.
the grade. Yes, sir.
Yeah. Tell me.
and in that the fixed vane is having a gradient like a slope. In one region it is of
See, kindly don't go by the construction. Don't research in the gate preparation or ESC preparation. If two iron pieces are placed in a region of same magnetic field, two iron pieces will be getting repelled and the iron piece will be moving. The pointer will be moving. The pointer will be showing the value. That's it. If you want to do this research after the MTech, do the PhD, then research.
Okay, sir. So, but my doubt is, it can repel in any direction, no, sir? That's what, sir.
It can repel in any direction, but based on the construction, right? Simple logic. If I start the bike can move in forward or backward. Why it is not moving backward?
Sir, because we are accelerating it forward.
Yeah, accelerator forward. How can you say accelerator, car is there, reverse gear, accelerator only you are pressing, but it is coming down? That depends on the construction. That's why I try to understand the faculty statements. If you consider, consider only. Need not to consider, need not to consider. If it is research oriented only. Okay. That's why I told you this is a competitive exam. Get the subject. With this subject, get the job or go to the PhD. Then take only I'm not satirically I'm talking here. I'm seriously talking because many people are having the same problem. Every batch one student will be there. Sir, kindly show me how it is moving. Go to the PhD.
Sir, I don't want to go into that detail. I was just asking. You explained in class that because of the inductance gradient, the gradient in the.
I did not say grade. I did not use the word gradient in my topic.
So why it will deflect in one direction? You explained that one word, right?
Construction based. Construction. One side locking will be there. Only one side it will be moving. Other side it will not move.
Less inductance, sir. Less. So you used one word like less inductance or
reluctance. Reluctance.
Okay, okay, sir. So that less reluctance, I am not observing it in any diagram. That's why I asked this question.
Means you don't have any electrical basics. It seems that's it. Simply this is the coil. This is iron piece. Where do we have less reluctance path? Means iron should move towards iron piece should move away. Here only you are getting confused, I think, right?
No, sir. Okay. Continue, sir. So it should move closer.
Closer. Why it is closer? Why it is not away? Means it is an attraction force. You are missing small thing. Attraction force and repulsion force. Attraction force and repulsion. Attraction force, the low reluctance will be which one here? Towards the coil. Towards the coil. That's why iron piece will be getting attracted. Iron piece will be getting moved towards the low reluctance. So why? Attraction. Attraction means this is always trying to pull this here. As it is pulling like this, the low reluctance will be towards it. That's why the iron piece comes here. But in the second case, this is the fixed iron. This is the moving iron. Repulsion, low reluctance will be away from each other. Therefore, if these two are repelled means the low reluctance will be away from this. Therefore, this is fixed iron. This moving iron, repulsion, it will be moving. Here also, it is moving low reluctance path only. Low reluctance side only. That's why kindly get this point, attraction repulsion concept.
Okay, sir. Thank you so much, sir.
Hello, sir.
Yeah, who is this?
Sir, one Sai Charan Reddy, sir. Sir, one small doubt, sir.
Yeah, tell me.
Sir, we will give input to the meters like if you consider in AC, Im sin omega t or Vm sin omega t. In case of ammeter and voltmeter, it will only sense the maximum value, and for RMS value it will be divided by √2, na, sir?
No. That is mathematically you are saying. Can you give instantaneous value to that device? Continuous supply you will give.
Yes, sir. Supply.
What does it mean? Can you give I equal to Im sin omega t value then? You're missing small things, I Charan. I equal to Im means only this point. You are giving only this point. This is instantaneous. Are you getting my point?
Yes, sir. Yes, sir. It an instant. Yes.
You are giving enter. That's Conceptually, we take that instantaneous value calculation point of view. You will be giving full scale value only. If it is a AC supply RMS value, 230 volt only we give. After that, from this 230 is the RMS into √2 sine omega t is the, what is it? Instantaneous. That is what the actual concept.
Sir, in case of power also same, sir. Measurement of
Everywhere.
power also.
Everywhere.
Yes, sir.
See, simple logic here. You are missing small thing. V of t into I of t. These are there, means power also same thing. Good
Yes, sir.
question. Very good.
Yes.
Right. Yeah.
11F, sir.
Yeah. Hello.
Yes, sir.
What's your doubt?
Sir, here, sir, ఇక్కడ TD proportion to IC IP అని రాశారు కదా సార్.
అవును. Yes.
అక్కడ మీరు cos phi ఎందుకు రాలేదు సార్? ఎందుకంటే IC లో ఒక రెసిస్టెన్స్ ఉంటుంది, IP లో ఎక్కువ రెసిస్టెన్స్ ఉంటుంది, అప్పుడు యాంగిల్ డిఫరెన్స్ ఉంటుంది కదా సార్. అప్పుడు మనం ఇక్కడ cos phi రాయట్లేదు ఎందుకు సార్? కన్స్ట్రక్షన్ లో అయితే రాసాం కదా సార్.
ఎక్కడ రాయట్లేదు? ఎక్కడ రాయలేదమ్మా?
11F సార్.
11F లోనా? 1 second.
Yes. ఇక్కడ సార్.
ఎందుకంటే ఇది కరెంట్ గురించి కదమ్మా.
అవును
కరెంట్
సార్.
అంటే రెండు కాయిల్స్ సిరీస్ లోనే ఉన్నాయి. రెండు కాయిల్స్ సేమ్ కరెంట్ ఫ్లో అవుతుంది కదా. అక్కడ ఏంటి, మీరు కాస్ ఎప్పుడు తీసుకోవాలి? కాస్
రెండిటి మధ్య యాంగిల్స్
కాదు. కాస్ అంటే ఏంటి? కొసైన్ ఆఫ్ ద యాంగిల్ బిట్వీన్
వోల్టేజ్ అండ్ కరెంట్.
ఇక రెండు కరెంట్ కాన్సెప్ట్ కదమ్మా. మీరు ఒక కాయిల్ ని ప్యారలల్ కనెక్ట్ చేస్తే వోల్టేజ్ కాన్సెప్ట్ వస్తుంది, అప్పుడు యాంగిల్ బిట్వీన్ తీసుకు. ఇక్కడ రెండు కరెంట్ కదా, అందుకని కాస్ ఫై ఉండదు. మీరు కాస్ ఫై రాసామంటే ఆటోమేటిక్ గా పవర్ కాంబినేషన్ కదమ్మా. ఇక్కడ ఏంటి మనకి కరెంట్.
ఓకే సార్. ఓకే సార్.
రైట్.
థాంక్యూ సార్.
రైట్.
హలో సార్.
యా
సార్, గుడ్ ఈవినింగ్ సార్.
యా గుడ్ ఈవినింగ్
సార్, అంటే ఒక స్టేట్మెంట్ చెప్తాను సార్, అంటే అది కరెక్ట్ కాదో చెప్పండి సార్ ఒకసారి.
చెప్పచ్చు. ఫీల్ ఫ్రీ, నో ప్రాబ్లం. యా
yes sir. Sir, is current carrying conductor placed in its own magnetic field can experience a force, sir?
డెఫినెట్లీ నో వే.
yes sir. ఎప్పటి నుంచే డౌట్ ఉంటుంది సార్.
సింపుల్ లాజిక్ చెప్తానండి.
ట్రాన్స్మిషన్ లైన్ లో కూడా, అంటే ట్రాన్స్మిషన్ లైన్ లో కరెంట్ వెళ్తుంది కదా సార్, దాని చుట్టూ మ్యాగ్నెటిక్ ఫీల్డ్ ఉంటుంది, కానీ అది మాత్రం ఫోర్స్.
అదే చెప్దాం. ఎగ్జాంపుల్ ఏంటంటే, మనం చూసే కండక్టర్స్ అని రొటేట్ అవుతానే ఉండాలి, మన స్టేషనరీ కండక్టర్స్ ఉండకూడదు. అందుకని సింపుల్ ఎక్స్ప్లెనేషన్ చూడండి. ఇది జనరల్ ఎలక్ట్రికల్ పీపుల్ కి, మాకు కూడా స్టూడెంట్ కొన్నప్పుడు చాలా రోజులు డౌట్. ఇది అడిగితే ఏమనుకుంటారన్న భయం, వెక్కిరిస్తారు, సిల్లీ డౌట్ అంటారు. సింపుల్ లాజిక్. ఇక్కడ ఒక కండక్టర్ ఉంది. ఈ కండక్టర్ లో క్రాస్ ఉంది అనుకోండి, మ్యాగ్నెటిక్ ఫీల్డ్ ఉంది. క్లాక్ వైజ్ తీసుకోండి. ఇక్కడ డాట్, ఇక్కడ యాంటీ క్లాక్ వైజ్ తీసుకోండి. సార్, కండక్టర్ క్యారింగ్ ఏ కరెంట్ ఈజ్ నాట్ ప్లేస్డ్ టువర్డ్స్ మ్యాగ్నెటిక్ ఫీల్డ్. ఇది ప్లేస్ చేయలేదండి. కండక్టర్ లో ఉన్న కరెంట్ ద్వారా వచ్చే మ్యాగ్నెటిక్ ఫీల్డ్ అది మనం ప్లేస్ చేయలేదు. ప్లేస్ చేయడం అంటే మ్యాగ్నెటిక్ ఫీల్డ్ అక్కడ అలాగే ఉంది, కండక్టర్ తీసుకొచ్చి పెడుతున్నాం. అలా పెడుతున్నామా లేదు. అందుకని స్టేట్మెంట్ లోనే వెనెవర్ ఏ కరెంట్ క్యారింగ్ కండక్టర్ ఈస్ ప్లేస్డ్ ఇన్ ద మ్యాగ్నెటిక్ ఫీల్డ్, దాని ఓన్ మ్యాగ్నెటిక్ ఫీల్డ్ దాన్ని తీసుకొచ్చి పెట్టొచ్చు. లేదు, ఎందుకు? దానికి కరెంట్ ఫ్లో అయితేనే ఓన్ మ్యాగ్నెటిక్ ఫీల్డ్ వస్తుంది. అర్థమైంది కదా? లాజిక్ అర్థమైంది కదా? అందుకని వెనెవర్ ఏ కరెంట్ క్యారింగ్ కండక్టర్ ఈస్ ప్లేస్డ్ ఇన్ ద మ్యాగ్నెటిక్ ఫీల్డ్ అంటేనే ఇట్ ఇంప్లైస్ అదర్ ఫీల్డ్. దాని ఓల్డ్ ఫీల్డ్ ఎలా పెడతాము అంటే, మీరు ఏమంటున్నారు అంటే, మీరు జనరల్ గా రైట్, ఓల్డ్ ఫీల్డ్ ఉంది, ఆ తర్వాత కండక్టర్ తీసుకొచ్చి కరెంట్ ఇస్తున్నాము. అరే, కండక్టర్ లేదు, కరెంట్ లేదు, ఎలా ఫీల్డ్ వస్తుంది? ఇది సింపుల్ టర్మినాలజీ టు అండర్స్టాండ్. ఆఫ్టర్ దట్ ఇది కొంచెం ఫ్లక్స్ ఇలా వచ్చిందండి. ఇది నార్త్ అనుకోండి, ఇది సౌత్ అనుకోండి. నార్త్ ఫ్లక్స్ ఇలా వచ్చేసి ఇప్పుడు ఏమవుతుంది? ఇలా బెండ్ అయిపోతుంది. ఎందుకంటే డౌన్ ఉంది కదా, ఇలా బెండ్ అయిపోతుంది. ఇలా బెండ్ అయిపోయి వస్తుంది. అప్పుడే ఈ బెండ్ అయిన ఫ్లక్స్ ఎప్పుడు కూడా స్ట్రేట్ లైన్ లోకి రావడానికి ట్రై చేస్తుంది. కాబట్టి ఇది ఇలా, అది మిషన్స్ లో చెప్తాను జనరల్.
సార్, అండర్ డౌట్ సార్. ఇప్పుడు అంటే ఇప్పుడు ఎలక్ట్రోమాగ్నెట్ అనేది, దాని యొక్క మ్యాగ్నటైజేషన్ అనేది వేరీస్ విత్ సప్లై కదా సార్. అంటే కరెంట్ ఎక్కువ అయ్యే కొద్దీ మ్యాగ్నటైజేషన్ ఎక్కువ అవుతుంది కదా సార్. సార్ ఇప్పుడు మనం ఇప్పుడు ఒకవేళ ఒక అంటే ఒక ఇన్స్ట్రుమెంట్, ఎంఐ ఇన్స్ట్రుమెంట్ తీసుకుని దాంట్లో హై కరెంట్ పాస్ చేస్తే దాని యొక్క ఎలక్ట్రోమాగ్నెటిక్ స్ట్రెంత్ అనేది పిఎంఎంసీ కన్నా ఎక్కువ ఉండొచ్చు కదా సార్.
అదేంటంటే మాగ్నిట్యూడ్ తోనే కాదు, నేచర్. ఈవెన్ దో ఇట్ ఈస్ హైలీ ఇన్ మాగ్నిట్యూడ్ అండ్ ఇట్ ఈస్ డిపెండెంట్ ఓన్లీ వన్ థింగ్. ఇంకోటి ఏంటంటే మీరు అడిగిన దానికి సార్ ఇప్పుడు రెండు ఈక్వల్ చేయొచ్చు కదండి, జాగ్రత్త చూడండి. మీరు ఏంటి ఇక్కడ 10 వెబర్ ఫ్లక్స్ ఉంది ఎక్కడ పర్మనెంట్ మ్యాగ్నెట్ లో. ఎలక్ట్రోమాగ్నెట్ లో కూడా 10 వెబర్స్ తీసుకొస్తే రెండు సేమ్ కదా అంటున్నారు, కరెక్ట్. బట్ ఈ నేచర్ ఏంటి, ఇండిపెండెంట్ అంటే స్ట్రాంగ్. ఈ నేచర్ ఏంటి, అది పాయింట్ ఇక్కడ. నేను కంపేర్ చేస్తే 10 కంపేర్ చేశాను, ఇది దీన్ని 10 తీసుకొని ఇది 5 తీసుకొని అలా కంపేర్ చేయకూడదు, ఎందుకంటే డిఫరెంట్ కెపాసిటీ మనం కంపేర్ చేయకూడదు. అందుకని 10 తీసుకున్నాను. బట్ ఇక్కడ ఏంటంటే 10 అనేది ఇండిపెండెంట్ స్ట్రాంగ్, 10 అనేది వేరియింగ్ వీక్. సింపుల్ లాజిక్ అండి. మీరు ఎవ్రీ సెమిస్టర్ లో 75% పాస్ అవుతున్నారు. ఓకే, అది ఈ ఎలక్ట్రోమాగ్నెట్ ఏంటంటే ఒకసారి 90% వస్తుంది, 30% వచ్చి ఫెయిల్ అయింది. ఏది స్ట్రాంగ్, అది మీనింగ్ అక్కడ.
ఓకే సార్,
సింపుల్ పాయింట్ అర్థమైంది. అందుకని నంబర్ మాత్రం కాకుండా నేచర్ ని తీసుకుని స్ట్రాంగ్ అని చెప్పాను, అది మీనింగ్. అంటే నేను హై అని చెప్పలేదు, స్ట్రాంగ్ టార్క్ అన్నాను. హై టార్క్ లో టార్క్ కదా అక్కడ, హై వాట్ ఇస్ స్ట్రాంగ్ టార్క్ అని.
ఓకే సార్, ఒక్కసారి EMMC కన్స్ట్రక్షన్ ఒకసారి ఆ పేజ్ నెంబర్ ఆ పేజ్ ఒకసారి తీయండి సార్. సార్ ఇక్కడ ఇప్పుడు మీరు 2 కాయిల్స్ పెట్టారన్నారు కదా సార్, అంటే 2 కాయిల్స్ గా చేసుకున్నారన్నారు కదా సార్ కరెంట్ కాయిల్ అనేది.
2 parts
సార్ ఇప్పుడు ఎస్ సార్. సార్ ఇప్పుడు ఈ ఫస్ట్ కాయిల్ లో వైండింగ్ అనేది ఒకలా వైండ్ చేసి సెకండ్ కాయిల్ ఇంకోలా వైండ్ చేసి, ఇప్పుడు ఆ మధ్యలో ఉన్న మూవింగ్ కాయిల్ కి దీని వల్ల అట్రాక్షన్, దాని వల్ల రిపల్షన్ వచ్చి హై, అంటే ఇప్పుడు ఒక దాన్ని అట్రాక్షన్ ఒక దాని రిపల్షన్ వచ్చి హై ఫోర్స్ ప్రొడ్యూస్ చేయొచ్చు, అంటే ఈ కాన్సెప్ట్ వాడుకోవచ్చు సార్. హై టార్క్
ఒకటి సింపుల్ అండి, అట్రాక్షన్ గాని రిపల్షన్ గాని అంటే కాయిల్ ఒక సైడ్ కి మూవ్ అయిపోవాలి, మనకు కావాల్సింది రొటేషన్ కావాలి. అందుకని ఈ 2 కాయిల్స్, ఈ 2 పార్ట్స్ ఆఫ్ ద కాయిల్ ద్వారా ఈక్వల్ ఫోర్స్ కంటిన్యూస్ గా వస్తుంది. అది అట్రాక్షన్ కాదు, రిపల్షన్ కాదు, ఈక్వల్ ఫోర్స్ కంటిన్యూస్ గా వస్తుంది. అందుకని 2 కాయిల్స్ ఉన్నప్పుడు మీరు ఏ విధంగా ప్లేస్ చేస్తారో దాన్ని బట్టి అట్రాక్షన్ రిపల్షన్ అంటాం. ఇది రొటేషన్ అంటే ఏంది, ఇది ఇలా వస్తుంది కాబట్టి అట్రాక్షన్, అలా కదండి. ఇదేంటంటే ఇక్కడ అట్రాక్షన్ రిపల్షన్ కాన్సెప్ట్ లేదు, ఎందుకంటే కరెంట్ క్యారింగ్ కండక్టర్ ప్లేస్డ్ ఇన్ ద మ్యాగ్నెటిక్ ఫీల్డ్ ఎక్స్పీరియన్సెస్ ఎ మెకానికల్ ఫోర్స్ కంటిన్యూస్లీ లైక్ దిస్, అంతే. అది పాయింట్.
అంటే సార్ ఆ మూవింగ్ కాయిల్ యొక్క ఫోర్స్ అనేది ఎటువైపు వెళ్ళాలి అనేది ఆ పక్కన అంటే మ్యాగ్నెటిక్ డైరెక్షన్స్ మీద కదా సార్ కొంచెం డిపెండ్ ఉంటుంది మూవింగ్ కాయిల్.
అది వెరీ గుడ్. అయితే పాయింట్ ఏంటంటే మూవింగ్ కాయిల్ ఎలా రొటేట్ అవ్వాలి అంటే ఏం చెప్పాను నేను, డైరెక్ట్ గా మనకున్న ఇన్స్ట్రుమెంట్స్ అన్ని కూడా రైట్ సైడ్ మూవ్ అవుతాయి, అవునా. లెఫ్ట్ సైడ్ మూవ్ అంటే ఆ కన్స్ట్రక్షన్ లో అలా డిజైన్ చేస్తారు దాన్ని, అంటే లెఫ్ట్ సైడ్ మూవ్ అవ్వకుండా రైట్ సైడ్ మూవ్ అయ్యేటట్టుగా డిజైన్ చేస్తారు. అది
అంటే ఓకే సార్, అంటే నేనేమన్నానంటే ఇప్పుడు మధ్యలో కాయిల్ పైన నార్త్ కింద సౌత్ తీసుకుని ఎలక్ట్రో
ఒక్క నిమిషం మీరు కంటిన్యూ చేయండి క్వశ్చన్. మీ క్వశ్చన్ లో ఆన్సర్ అంటే పైన నార్త్ కింద నార్త్ తీసుకోలేము మనం, ఎందుకంటే నార్త్ సౌత్ అనేవి వేరీ అవుతా ఉంటాయి, ఎందుకంటే ఇది ఎలక్ట్రోమాగ్నెట్.
ఏసీ కాబట్టి
అది కదా మిస్ అవుతుంది, అది ఎలక్ట్రోమాగ్నెట్. ఇది అంటే ఏంటి, ఒకసారి పాజిటివ్ సైకిల్ నార్త్, నెగిటివ్ సైకిల్ రివర్స్ అయిపోతుంది కదా, అందుకని ఇక్కడ అట్రాక్షన్ రిపల్షన్ అనేది ఉండదు. అంటే ఇప్పుడు అర్థమైంది కదా క్లారిటీగా?
అర్థమైంది సార్. అది అంటే కాన్స్టెంట్ గా ఏది ఉండదు, అట్రాక్షన్ ఉండదు, రిపల్షన్ ఉండదు, కానీ ఫోర్స్ మాత్రం అది
రొటేషన్ అవుతా ఉంటుంది.
ప్రొడ్యూస్ చేస్తుంది.
అది
ఓకే, థాంక్యూ సార్.
రైట్, ఆల్ పీపుల్ డౌట్స్ క్లారిఫైడ్. Okay then. Still a doubt is there? We can discuss tomorrow.
Sir.
Yeah. Oh, on switched on. Yeah. Who is this? Yeah, tell me.
Sir, Abdul sir.
Yeah.
Sir, एक बार आप electrostatic instruments why we have prefer the voltmeter एक बार बोलो sir.
एक बार okay ठीक है. Only why voltmeter like that right?
हाँ जी जी.
ये पूरा derivation में क्या यार हमें theta proportional to v square आ गया.
हाँ.
Okay. See ये सर्किट में देखे तो V यहाँ पे दिया, ओके, सप्लाई यहाँ से दिया
जी,
ओके राइट. ये सर्किट के दोनों का प्लेट का बीच में एयर गैप है या कंटिन्यूस पाथ है?
एयर गैप डायरेक्टर मीडियम रहता ना,
डायरेक्टर मीडियम है. डायरेक्टर मीडियम रहे तो भी ये प्लेट और ये प्लेट दोनों कनेक्ट नहीं कर सकते राइट फिजिकली. क्यों? ये दोनों के बीच में ऐसा कनेक्ट करते, ठीक है. सो डू वी हैव कंटिन्यूस कनेक्शन? कंडीशन कनेक्शन है क्या अपने पास? नो। क्यों? थ्रू द डाइलेक्ट्रिक मीडियम है, वो एक बात है, ठीक है। और फिर भी डाइलेक्ट्रिक मीडियम कनेक्ट करने के बाद भी अगर करंट फ्लो हुआ, इसे हम क्या बोलते हैं? डिस्प्लेसमेंट करंट बोलते हैं, एक्चुअल करंट नहीं।
हाँ, जी जी
सही ना? ठीक है। इसमें ओके कुछ तो करंट फ्लो हो रहा, ये करंट फ्लो हो रहा। मेरा पॉइंट क्या है तो वोल्टेज के वजह से करंट फ्लो हो रहा और करंट के वजह से वोल्टेज एग्जिस्ट हो रहा।
तो वोल्टेज के फोर्स है ना सर, फोर्स डेवलप हुआ उस
नहीं, वोल्टेज की वजह से करंट आया या करंट की वजह से वोल्टेज आया?
सर आप क्योंकि तो आप एक स्टेटमेंट दिए ना सर, व्हेनेवर फ्रॉम द ओम्स लॉ, व्हेनेवर करंट फ्लो ऑफ इलेक्ट्रॉन्स के वजह से इज प्रोपोर्शनल टू पोटेंशियल डिफरेंस।
हाँ, क्या है बात? आई प्रोपोर्शनल वी बोले तो क्या है? करंट फ्लो इज बेस्ड ऑन द वोल्टेज।
हाँ,
आई करंट फ्लो, दैट्स व्हाई ये करंट वोल्टेज की वजह से आ रहा, ठीक है।
ओके ओके।
बट वोल्टेज करंट की वजह से नहीं आ रहा, वोल्टेज की वजह से करंट आ। अब देखिए थीटा प्रोपोर्शनल वी स्क्वायर आ गया। अगर मैं ऐसा लिखना बोले तो क्या है? वोल्टेज डिपेंड्स ऑन करंट, वोल्टेज करंट के वजह से आ रहे, सो करंट रिफरेंस हो गया। कैसे हो सकता है यार? नो, इसके वजह से ही ये आ गया।
ओके,
इसलिए राइट, एम आई में क्या आया? आई स्क्वायर प्रोपोर्शनल टू वी स्क्वायर। यस, हाँ, वहां पे कंडक्टर है, कॉइल है, से करंट वोल्टेज के हिसाब से आता है, ठीक है, बट वोल्टेज करंट के हिसाब से नहीं आएगा।
अच्छा,
दैट्स द पॉइंट।
इसलिए हमें वोल्टमीटर प्रेफर करते सर।
नहीं, एमीटर मेजर नहीं कर सकते, करंट मेजर नहीं कर सकते,
ठीक है सर, ओके।
इसलिए वोल्टेज ही आएगा, दैट्स व्हाट।
अच्छा, इसीलिए सिर्फ वोल्टेज ही आएगा।
हाँ, वही डायरेक्टली। तो एक बात है, डायरेक्टली तो आपको वोल्टेज आ गया,
ओके,
ठीक है, राइट। अगर करंट भी आ सकता कि नहीं, वो देखने के लिए वो इक्वेशन बता के मैं करंट मेजर नहीं कर सकते। क्यों बोले तो वोल्टेज करंट के ऊपर नहीं डिपेंड होता, इसलिए वोल्टेज ही मेजर कर सकते, केवल वोल्टेज ही मेजर कर सकते।
अच्छा सर, और एक सर, आप आज का क्लास नहीं सर, इसके जो प्रीवियस क्लास है, एक प्रॉब्लम है सर, उसमें क्या है कहते हो, ए Wheatstone bridge required a change of 7 ohms in the unknown arm bridge to produce a change in deflection of 3 mm. हाँ, ये इसमें क्या है कहते सर, चेंज ऑफ 7 ohm का है ना सर पहला लाइन, ये 3 ohm से।
Change of 7 ohm is producing the change in deflection.
नहीं सर, मैं क्या बोल रहा हूँ तो R इक्वल टू रो L by A में अगर हमें L को चेंज करे तो कंस्ट्रक्शन में आउटपुट क्या है? रेसिस्टेंस भी चेंज होता बोल रहा हूँ मैं। नहीं सर, मैं ये नहीं, आपका पॉइंट ऑफ व्यू नहीं सर, एज पर दी बोल रहा हूँ मैं, मशीन का कौन सा भी हो।
One second. No, you are missing small thing. This is not the length of resistor. You are missing something. This is not the length of resistor. You are thinking that sir resistance बदले तो length कैसे बदलेगा? Actually length बदले तो resistance बदलना, वही बोले ना?
हाँ जी।
हाँ, नहीं यार, एक्चुअली क्या बोले तो एक ब्रिज सर्क्यूट में एक गैल्वेनोमीटर बोल के डिवाइस है, वो बाद में आ जाता है, बट ठीक है, राइट। मैं ये रेजिस्टेंस को वेरी करे तो ये पॉइंटर, जो पॉइंटर है वो पॉइंटर डिफ्लेक्शन 3 mm हो रहा, वो दिया हूं।
अच्छा,
एमीटर की डिफ्लेक्शन कौन सी टेक्नोलॉजी में देना? थीटा में देना। कंफ्यूज करने के लिए एंगुलर डिफ्लेक्शन को इन कैसे दिया? इंस्टेड ऑफ गिविंग थीटा mm में दिया। दैट इज द पॉइंट।
इसलिए आउटपुट डिफ्लेक्शन होता 3 mm।
डिफ्लेक्शन वो लेंथ चेंज है, डिफ्लेक्शन है, ये इनपुट है।
अच्छा, मैंने सोचा कि ये आपका मेजरमेंट सब्जेक्ट को आप ऐसा बोल रहे हो ना, नॉर्मल में ऐसा नहीं होता ना सर, इसलिए बोल रहा था मैं।
नहीं, नॉर्मली तो लेंथ के ऊपर रेजिस्टेंस, एरिया ऑफ क्रॉसेस के ऊपर रेजिस्टेंस, रो के ऊपर रेजिस्टेंस, ये चेंज हुई तो ये चेंज होता।
हाँ, इनपुट आउटपुट
एलिमेंट की बात है,
चेंज हो जाती है,
या वो एलिमेंट की बात है। बट यहाँ पे क्या है, एक सर्क्यूट में रेजिस्टेंस चेंज करे तो वो सर्क्यूट में करंट डिफ्लेक्शन होता ना, वो करंट डिफ्लेक्शन पॉइंटर डिफ्लेक्शन दिया हूं। दैट्स व्हाट द पॉइंट।
अच्छा। ओके, थैंक यू सर, थैंक यू।
राइट, ओके एवरीवन।
जी, ओके, थैंक यू। हाँ, थैंक यू।
राइट, Good night. We'll meet.